Welcome to AWS Certified Database Specialty Training course. Let me briefly introduce myself as an instructor. I have experience in developing enterprise systems and cloud architecture for some major companies. Besides this course, I offer tutorials on cloud service and programming on Udemy and YouTube. I also offer courses to prepare for other certification exam and tutorial on other cloud services like Google Cloud and Microsoft Azure and AWS. This video course is tailored for those aiming to pass the AWS Certified Database Specialty exam. It includes about 8 hours of video explanation covering the key topics that will appear in the exam. The course comprehensively covers all the services included in the exam syllabus, and hands-on video tutorial provided enabling the practical learning, and practice questions are also available. In closing, I hope your success in passing the exam and furthering your skills. Thank you for listening. This video is a YouTube version. The full version of this course is available on Udemy, where it covers all the services featured in the Database Specialty exam. The Udemy version includes a hands-on video and practice test. I've posted a discount coupon for the Udemy course in the video description. And feel free to comment anytime if you need a coupon issued. Welcome to the AWS Database Specialty course. This course is divided into the 4 main sections. In Section 1, AWS Certification Exam and Preparation, I will introduce an overview of the exam and some tips on how to study for it. In Section 2, Introduction to each service, I will cover all the services that could come up in the exam. In Section 3, Practice Question, I will provide the insight and the guidance on taking the exam. And lastly, in Section 4, the summary, I'm going to introduce the additional learning resources. Alright, let's dive into Chapter 1. In this section, I'm going to introduce an overview of AWS, the detail of the certification exam, and how to set up an account. Now, first off, I'm going to introduce what AWS is all about. AWS, or Amazon Web Service, was founded in 2006 and has grown to become the leading cloud platform. It began its journey as a service within Amazon.com and gradually expanded to offer the services like the virtual server and storage. It's known as the infrastructure as a service. Today, they now offer over 240 services and continue to grow their market share. AWS offers its service globally. As long as you have the internet connection, you can access their services. Their services are available in 245 countries and territories, with 32 regions and over 100 availability zones. This is a cloud market share. Over the past few years, AWS has held about a third of the global cloud market share, followed by Azure and Google Cloud. Since its inception, AWS keeps top share. The AWS certification is highly recognized and is one of the most popular in the IT world. This is a comparison between cloud and on-premises. One of the primary advantages of the cloud service is the ease of deployment via the internet. Also, you pay for what you use, which often means a reduced cost for the user. But the benefits of the moving to the cloud are not just about the cost saving, and the standardization at the infrastructure can also simplify the management. And lastly, for your reference, I'd like to introduce the comparison chart for the three major cloud providers given by Google Cloud. All three cloud providers offer similar services. If you've had experience with Google Cloud or Azure, this comparison helps you understand AWS well. And for those looking to study not only AWS, but also other cloud services, this document can be handy. Next, we introduce the overview of the certification exam. Before we start, I want to talk about something that might sound a bit preachy. And you might see people online comment like, I passed in just a few weeks, or I passed even though I'm beginner. But remember, the way of learning is different person by person. Your background, how fast you learn, your personal life and work life, all these things affect how much time you can dedicate to studying. It is important to find the pace that works for you. When it comes to studying, there is no one-size-fits-all approach to studying. And the learning style is different by person, and the time needed to pass the exam is also different by person. And easy and hard are subjective, and are not universal truths. In addition, the Roma was not built in a day. The engineering skills are built over time. The IT world is rapidly evolving, so there is no end to learning. Make the most of any free time and find a suitable way to keeping learning. Earlier, I told you that the way of studying different from the person to person, and in this course, I will break down the AWS services by category, and after that, providing the practice question. Whether you want to dive into the lecture first or tackle the question is totally up to you. Thanks to the platform like Udemy, you can easily learn technology and business skills. This means the more willing you are to learn, the more you can grow. The benefits of the on-demand learning includes as long as you have internet access, you can learn anytime, anywhere. You can attend the lecture by popular instructor regardless of where you are. And it's flexible. You can adjust the playback speed and revisit specific sections. But the drawback of the on-demand learning includes unlike classroom, you may find it difficult to concentrate. Because the teacher-student relationship is one too many, it's hard to ask questions in real time. But in this course, I will try my best to answer your questions. And here is an overview of the AWS certification exam. There are three levels: foundational, associate, and professional. And there are currently no prerequisites for taking the exam, so you can take the exam whenever you want, depending on your experience and skills. Specialty level includes the DevOps, networking, Alexa skill builder, security, machine learning, database, and data analytics. This is the top paying ranking of the IT industry. It is notable that there are 3 AWS certifications in the top 10. Including the Google Cloud and the Microsoft Azure, there are 6 cloud-based certifications in the top 10. Today, the cloud computing is the most important skill for not only infrastructure engineers, but even every IT engineers. If you want to broadly advance your career in the IT industry, it is highly recommended that you study for cloud certifications. The exam format is the multiple choice or multiple response. Choose one or more of the options A, B, C, and D. The exam duration is 180 minutes and there are 65 questions, but only 50 actually affect your score. The remaining 15 questions are used by AWS for research purposes. The score is a scale score. The score varies depending on the question. The passing score is 715 and the exam cost is $300 US. This is the content outline for the certification exam. The exam guide provides the weight and the content domain. There are 5 areas covered. The workload-specific database design 26%, deployment and migration 20%, management operation 18%, the monitoring and troubleshooting 18%, and database security 18%. In the last, this is the sample question. Since the database specialty is the database specific certification, you will need to focus on the database services. I have designed the course to cover scope of the certification exam. I will introduce to the actual services starting in the next chapter. Next, I will introduce to the creating an account. Many of you may already have the account, but I have included it for your reference. First, I will introduce the tools provided by AWS. The tools for development and management application in AWS includes the Management Console, CLI, and SDK. The Management Console, or simply Console, is a tool that allows you to manipulate the AWS graphically via web browser. It is the first page you access after creating an account with AWS, from which you can access various services. The CLI, or command line interface, is a tool to control the service via command line. You can access the environment using the access key and the secret key. There is also the CloudTrail, which allows you to access the console once and control the CLI from your browser. And this allows you to manipulate the CLI without any prior setup. The SDK, Software Development Kit, is a tool for development of various AWS services. It provides the language-specific API for each AWS services, such as Python and Go. And this one also allows you to access the AWS environment with an access key and secret key. And this is the step to create a root account and IAM user. And first, create a new AWS account, then set up IAM user. The IAM is the service that manages the permission of users in AWS. I will explain it again in the following chapter. First, search AWS in your browser and go to the AWS web page. You will see the button in the upper right corner that says Sign in to the console and click it. If you already have an account, you can sign in from this page. To create a new account, click the Create New Account. Enter your email to authenticate your email. A verification email will then be sent to that email address. And next, enter your personal information such as address, the credit card, a phone number. The credit card or debit card is required for your billing, even if your billing is zero. If you are not belong to corporation and use AWS for personal development or just learning, I recommend you to choose the basic plan, which is the free of charge. For developer plan and the business plan, you can get the support from AWS customer engineers. Once you have completed this process, AWS account will be created successfully. And this is the page called the Management Console. You will be the main page when you use AWS resources from now on. Now, I'm going to configure IAM. The first account that created is called the root user, and it will be the powerful account like administrator with access to your credit card. If the account is compromised, there is a security risk. Therefore, AWS recommends that you create an IAM user and sign in as the IAM user instead of using the root user normally. And first, type IAM in the search window above and move to IAM dashboard. And this is the IAM dashboard. In initial state, root user has MFA is marked with the red triangle. It is recommended that you install the token apps on your smart device. And the next time you sign in as a root user, authenticate with MFA. And next, create an IAM user. The next time you sign in as usual, sign in as the IAM user. You should not sign in as the root user except when checking your credit account. Click on the user in the left menu and then Add User. Set the username and check the access key and the password field for the credential type. The access key is used for the API, CLI, and SDK, and the password is used to sign in to the management console. Select the Attach Existing Policy directory and choose the Administrator access, and this will give the IAM user all privileges except the credit card access. You can set tags any text you like. Tags allow identification of IAM user. If you create multiple users in the future, you may set tags to identify each users. And after successfully creating a user, be sure to save the access key and password that are displayed. You can also download the CSV format. When you have done set up IAM, you will return to the console again, and I will briefly introduce you to the structure of the screen. From the menu bar above, you can move to the various management screen, and you can return to the top page by clicking on the AWS logo on your left. Click on the Services to see all the services offered by AWS by category. You can also register frequently used service as favorites. Click on the CSI logo to open CloudShell. By doing so, you can manage the command line from within your browser as well. Click on the bell mark to view various notifications. You can find out about events, changes, and the incident for the service you are operating. Click on the question logo to get support. The type of support available depends on the plan. For example, the basic plan allows the ticket-based question about the fees, while the technical support is available with paid plans. By clicking on the gear logo, you can edit the language, the visual mode, and so on. And this is a recently added feature. The menu bar configuration may change in the future. Next, click on the pull down where the region name is listed to navigate to AWS region. The North Virginia is selected by default. Basically, by selecting the region that is close to where you want to deploy your services, and you can access your resources with low latency. Also, the services deployed and the fees vary slightly by region. Since AWS is a US company, so releases are generally the earliest in the US region, and are then after rolled out to other regions. And the documentation and other information also available in English for the latest services, and is gradually being translated into the other languages. And finally, you can check the account information you have created from the upper right corner of the console screen. Clicking on the organization will take you to the AWS Organization Service page, where you can view the information about the organization you belong to. From here, you can also check your service quota, usage status, and so on. If you need to access the credit information, you will need to sign out of your IAM user and sign in as the root user. Let's start Chapter 2. Here I'm gonna introduce each services. Firstly, I would like to explain the outline of the database world. I'm gonna show you the brief history of the databases. The history of relational database dates back to the 1970s. In 1977, the Oracle was released as the world's first commercial RDBMS. Following that, the PostgreSQL in 1986 and MySQL in 1995 were deployed. In 2000, NoSQL database were developed with increasing the demand for scalability and flexibility in web application. NoSQL represents the new type of the database designed to overcome the limitation of traditional relational databases. In 2007, the document-oriented MongoDB was introduced, and Cassandra by Facebook in 2008, and the in-memory store Redis in 2009. Today, with cloud computing, the database as a service has been developed. Since the foundation of the AWS 2006, the Amazon RDS was launched in 2009, initially supporting only MySQL and later support PostgreSQL, Oracle, Microsoft SQL Server, MariaDB, and Amazon Aurora. The Amazon DynamoDB is a key value store, and Amazon Redshift, a data warehouse service, were generally available in 2012. Followed by the introduction of AWS proprietary Amazon Aurora in 2014. Amazon Neptune was released in 2017, and Amazon DocumentDB in 2019. These are the types of databases. The conventional table type database are called RDB or relational database, and generally known as Oracle or MySQL. And the relatively new type of data format is called non-relational or NoSQL. And NoSQL includes the services such as key value, document, and the graph types. Here is a list of the database provided by AWS. Aurora, RDS, and Redshift as the relational database, and DynamoDB as NoSQL, the ElastiCache and the MemoryDB as the in-memory database. The DocumentDB is a document-oriented database and so on. In this call, I will cover all the database services released by AWS. I will describe the general benefits to migration your database from on-premise to AWS. AWS Database offers free managed support for patching, operating system, and the database management system, as well as backups and snapshot. In other words, customers do not need to manage infrastructure or servers. For example, on-premise, when a large number of requests are sent, the customer must manually build more servers. This requires a lot of overhead. But in AWS, you don't have to worry about it. Also, it takes a lot of time to update the version of the database management system. In terms of minimizing the management overhead, AWS has an advantage over on-premises. With AWS, you can easily create the high availability. Imagine having the physical server in multiple locations on-premise. It requires a great deal of man-hours. But with AWS, you can build a master and replica or master or standby server with just a few clicks. If a failure occurs on the master, the standby server is automatically promoted to the master server. AWS also supports the synchronized replication and the automatic failover. In terms of performance, AWS Database Services support read replica, that you can create read replicas across regions. In addition, it integrates with the reporting and monitoring tools such as the CloudWatch, CloudTrail, and cloud logging. The AWS supports many security features such as encryption at rest and in transit, and across the control by IAM. And the advantage of pay-as-you-go pricing. And next, I'm going to into the asset properties. The asset properties are fundamental concepts that ensure our database transactions are processed reliably. The first is atomicity, and this means that all the steps in the transaction get completed, or none of them do. If even one step fails, the whole transaction is rolled back, as if it never happened. And next we have consistency. After the transaction, the database must be correct and valid. A transaction never leaves the database in half-finished state. Isolation is our third property. Even if many transactions happen at the same time, each one is kept separate. They don't interface with each other. And lastly, durability. Assure us that once transaction is committed, it will stay, even if there is a system failure. It's like saving a document and knowing it won't disappear. Now I will use a specific example to illustrate what asset properties are. Let us consider a scenario in which the 100 Japanese yen is drawn from the Mr. A's bank account and added to Mr. B's account. Regarding the atomicity, if the system crashes before the money is added to the Mr. B's account, the transaction is completely rolled back, and the money is not withdrawn from the Mr. A's account. And for consistency, before and after the transfer, the total amount of money in the system remains unchanged. In other words, the total yen withdrawn from the Mr. A's account accurately reflected in the Mr. B's account. And for isolation, after a Mr. A's transfer is completed, it is reflected in the Mr. B's account. In other words, it is not reflected in the Mr. B's account before Mr. A's transfer is completed. And for durability, once the transfer operation is successfully completed, the result is permanently stored in the database. Even if a failure occurs in the system, the data is not lost. Next is the base properties. The base is the set of principles for databases that focus on the high availability and tolerance to network partitions, with eventual consistency rather than immediate consistency. It stands for the basically available. The database appears to work normally most of the time. The soft state. The state of the database may change over time, even without input. And eventually consistent. The database will become consistent over time, but doesn't guarantee immediate consistency. This is the agenda of this course. The agenda for the exam guide for Database Specialty exam. And first, I will explain the database-specific design. The section includes the design characteristics of each database services. In the scope of Database Specialty exam, all database services AWS are included. On the other hand, RDS, Aurora, and DynamoDB will actually appear on the exam for the most part. Therefore, I will focus on the RDS, Aurora, and DynamoDB. Next, in deployment and migration, I will introduce CloudFormation and DMS and SCT as migration services. In the management and operation, I will explain the backups, maintenance, but since those operations of each database is unique, so I will cover them in the database design section. The monitoring and troubleshooting, I will cover CloudWatch, CloudTrail, and Config. And finally, the database security, I will introduce the KMS, Secrets Manager, Network Security, and IAM. In this chapter, I will introduce to the all database service offered by AWS. The first of is the Amazon RDS. In this chapter, I will introduce each database service in the following order: a database-specific design, deployment and migration, management and operation, the monitoring and troubleshooting, and security. First, let me introduce the database design. Amazon RDS is the most popular relational database service. It's easy to set up, operate, and scale. As a managed service, it simplifies the administrative tasks such as the database configuration, patching, and backups. RDS supports a wide variety of the database engines: MySQL, PostgreSQL, MariaDB, Oracle, SQL Server, and Amazon Aurora. The Amazon Aurora has much in common with Amazon RDS, as we will see again in the next chapter. The RDS is highly scalable, scaling the database instance computing resources and storage based on the request. RDS excels in the high availability and the disaster recovery. It increases the availability and fault tolerance through the multi-AZ deployment. The RDS leverages a variety of AWS security services to support access control and encryption. The security includes the authentication and authorization, the encryption at rest and transit, and network security. The RDS supports automatic backups. The database can be backed up automatically or snapshots can be taken manually. The RDS is managed service and automates the software patching. And while the maintenance is expected to cause minor downtime and increase the latency, you can set up a maintenance window to control when the maintenance is performed. And for monitoring and notification, the RDS integrates with Amazon CloudWatch to monitor database performance through the real-time metrics. The RDS allows users to configure read replicas to scale the read traffic and create read-only copies of your database. The Aurora is a database engine developed by AWS. Since the Aurora can be used as the engine for RDS, the RDS and the Aurora have much in common. The storage types available are EBS generated purpose SSDs and provisioned I/O SSDs. For availability and performance, a multiple AZ configuration is available. A read replica can also be provided to improve read performance. When the primary instance fails, the read replica can be promoted to the primary instance. The read replicas are often appeared in every certification exam. The read replicas not only reduce the load in the instance, but also provides the failover architecture by promoting the read replica to the primary instance in the event of failure. I'm going to introduce the element of RDS. The RDS offers multiple instance types like other computing services. And here is an example of RDS instance type notation. The notation is almost the same as for EC2 instances. The table shows the instance family of RDS. The instance family are roughly categorized into the general purpose and memory optimized types. And you can choose a processor as an additional feature. And you can also choose your instance size. Generally, the larger the size and the higher the specification, such as the CPU and memory, the higher the unit price is. In practice, you should gradually increase the size and adjust while performing tests. Storage types include the general purpose SSD, the provisioned IOPS, and magnetic. The only magnetic is the HDD, and the others are SSD. The magnetic is used for legacy compatibility and is not recommended for usual use. And in RDS, the storage is automatically scaled when free space remains below 10% for 5 minutes. The next up is RDS proxy. The RDS proxy reuses available connection from the connection pool when it receives a connection request from the application. And this can reduce the latency in establishing a new connection. If you don't use the RDS proxy, a connection is made each time a connection is requested. The RDS proxy multiplexes many connections from the application into the database with fewer connections, and this increases the efficiency of the query. It maintains the connection from the application even if the database is temporarily unavailable. This improves the fault tolerance. Its proxy supports the IAM and the VPC security groups, which also improve the security. And you can also improve read performance by caching the result of your queries. So let's talk about the read replicas. A read replica is an instance that is replicated from the primary instance and is for read-only use. A read replicas are replicated asynchronously from the primary instance. And you can create up to 5 read replicas with RDS. And the read replicas are primarily used to offload application read processing. If you perform a write and read operation simultaneously on the primary instance, the load of the primary instance becomes concentrated. And therefore, you should distribute the load by offloading read processing to read replicas. And read replicas also asynchronously replicate the data from the primary instance, so they can be promoted to the primary instance. And you can take advantage of this property and use read replica for purposes such as disaster recovery, migration, and copying. And I will explain tips for the read replicas. And you can create a read replica in different regions. And you can use read replica for migration to another region or for cross-region disaster recovery. A connection endpoint exists for each read replica, and you can focus connection only on the read replicas. The RDS has a multiple AZ replication function, but unlike the replication, the read replica do not degrade the read performance. The constraints for the read replica differ by database engine. For SQL Server, it's currently available only in the Enterprise Edition. And also in the case of SQL Server, it is not possible to create a read replica in other region or multi-AZ. And for Oracle, it is only available in the Enterprise Edition, and you need to use Active Data Guard to use the read replicas. Also, the read replica in mount mode cannot be read. In other words, the read replicas cannot be used for the purpose of distributing the read load, but only for disaster recovery purposes. I will explain the cost structure of RDS. The RDS costs on the pay-as-you-go basis, with charges for instances, storage, and data transfer. Then I will introduce the cost element from the next page. Since the price is charged over time, I will focus on the concept of the cost. The billing unit for instance is 1 hour. If less than 1 hour, you will be charged by 10 minutes. Additionally, you will not be charged while the instance is stopped. The larger the instance size and the higher the specs, the higher the unit price is. The memory optimized types tends to have higher unit price than general purpose types. The unit price also varies depending on the database engine. The Oracle is more expensive than other database engines because it includes a license fee. In RDS, you can use reserved instances. Reserved instances offer certain discount for long-term usage of 1 or 3 years. Also, the more you pay in advance, the bigger the discount will be. For storage, you will be charged for the amount of storage and I/O. The unit price differs between the general purpose SSD, the provisioned SSD, and the magnetic. The RDS supports multi-AZ, and multi-AZ doubles the storage and therefore doubles the cost. And you are also charged for the backup storage, but the unit price is lower because the backup storage is not hot storage, but cold storage. When it comes to the transfer, the data transfer to RDS are free, and the outbound transfer are charged per gigabyte. And next, I'm gonna introduce deployment and migration. When it comes to database migration, there are migration from on-premise to AWS or other cloud service to AWS. The way of migration varies depending on the database engine. Here I will introduce some representative ones. The MariaDB is a database engine derived from the MySQL, so the migration process is similar between MySQL and MariaDB. A typical migration is to import backup file directly into RDS instance, and it also supports migration using MySQL commands, for example, MySQL dump or MySQL import for data migration for data larger than 1 GB. And for SQL Server, you can import into the RDS via S3 using backup file. The migration of schema, stored procedure, triggers, and etc. are also supported. For Oracle, you can use Oracle utilities. You can use the Oracle SQL Developer, Oracle Data Pump, Oracle Export and Import utility, and Oracle SQL Loader. You can also continuously synchronize the data by using Oracle Materialize View. The Materialize View is the view that displays the latest data synchronously. In PostgreSQL, you can use PD dump and PSQL to perform the database export and the data loading. And you can also perform migration using the copy command and the PG transport. Next is the from RDS to RDS migration. Between the same database engine, you can perform the migration using the snapshot and the read replica. When migrating using the snapshot, they create a snapshot from an existing database and then create a new database from the snapshot. And when migrating using the read replicas, they create a read replicas and promote it to the primary instance. In particular, migration using the read replica is often asked in the certification exam. And when using the different database engine on the source and destination, it is common to use Amazon Database Migration Service or DMS. I will introduce the detail of DMS again in the following chapter. You can also migrate from RDS to Aurora. When migrating from the RDS to Aurora, the database engine must be same on the source and destination. Next, I'm going to introduce management and operation. And here I will explain the backup and maintenance. The RDS supports automatic backup and manual snapshot and point-in-time recovery. And for auto backup, it performs backups once a day and retain for up to 35 days. And you can also take a manual snapshot up to 100 at any time. The RDS also supports point-in-time recovery. I will explain more detail about the backup. The retention period for automatic backup is 0 to 35 days. If you set 0 days, no backup is created. The default setting is 7 days. The first backup is a full backup, and the second and subsequent backups are differential backups. In other words, only the changes are backed up, and the snapshots are stored in the S3. The automatic backups are performed once a day. On the contrary, you can take manual backup at any time. The snapshots are stored in S3, so they can be copied to another region or another account. When copying to another region, KMS key, parameter groups, and the option group will not be copied. The KMS must be configured for permission at destination. With AWS Backup, you can specify the time instead of the days, and the AWS Backups offer migration automation. When restoring the snapshot, a new DB instance will be created. You cannot restore a snapshot to an existing database. The connection endpoints are also newly created, so you will need to configure networking settings such as DNS for the new endpoint. And for point-in-time recovery, the restores are performed using the transaction logs that are stored in S3 every 5 minutes. And you can specify a time to perform a point-in-time recovery. The restoring from the point-in-time recovery also creates a new instance. In other words, you cannot restore a snapshot to existing DB instance too. Next, an explanation of the maintenance. Since RDS is the managed service, the patching and the upgrades are performed on the AWS side. The maintenance may cause a slight downtime and latency, so it requires the maintenance be performed at times that have the little impact on the operation, such as during the night or on holidays. The time period during the maintenance is performed is called a maintenance window. The maintenance window runs for a user-specified 8-hour window. By default, it runs between 10 p.m. and 6 a.m., and usually within 30 minutes. In the multi-AZ configuration, the standby instance is maintained first. And once the standby maintenance is complete, the standby switches to the primary. The database engine upgrades are performed simultaneously. And you have to do the major upgrade of the database engine manually. And you may choose to have the minor upgrade done automatically or manually. And if you have the business impact or compatibility concern, you can do it manually. And you can specify the parameter groups for RDS. A parameter group is the group of the parameter which you can customize settings related to the database behavior and performance. And you can associate the parameter group when you create a new DB instance and cluster. And you can change the parameter group of the existing DB instance and cluster, but you may need to restart it for the changes to take effect. Apart from the parameter group, if you want to associate additional functionality or a specific third-party application with the database instance, you can set up the option groups. And with option groups, you can associate the specific option groups with the new and existing DB instances. It may take effect immediately or may require restart to change option groups. depending on the impact on the DB instance. And next, I'm going to introduce monitoring and troubleshooting. And with RDS, you can get instance level metrics, network, and storage metrics through the CloudWatch. And however, you cannot get the metrics about the performance of a database, such as number of successful queries or wait time with CloudWatch. And here are some examples of metrics that can be obtained with the CloudWatch. And with CloudWatch logs, you can also get logs like one listed here. You can get error logs, general query log, slow query logs, audit log, and binary logs. And for OS level metrics that cannot be got with the CloudWatch standard metrics, you can use the extended monitoring. The extended monitoring includes the detailed OS level metrics. For example, it includes the CPU usage, memory usage, disk I/O, and so on. If you want to get metrics on database performance, enable Performance Insights for RDS. The Performance Insight provides a visibility into performance at the SQL level. The metrics that can be obtained with the Performance Insight include the SQL wait events and the database load. And you can visualize the insight by filtering the specific period of time, so you can see which query affects performance. The Performance Insight can store performance for 7 days by default and up to 2 years. And next, I will introduce some troubleshooting in RDS. For connection errors, you need to configure your VPC, a set security group, and network ACL permission, and check if ports are open or not. And for performance issues such as the small instance type or high I/O wait time, you should identify the bottlenecks in the Performance Insight or CloudWatch and try to optimize queries or change to an appropriate instance type. And if you are running out of the disk space, you should try to remove unnecessary data, expand storage, and change instance types. For backup and restore, if there is excessive use of the I/O during the backup or incomplete backups, you should try to change the backup window, decrease the I/O usage, or verify snapshot integrity. There may be a slight increase in the latency in getting the backups, and if the DB instance is heavily loaded, backup integrity may be the compromise. Therefore, you should typically do a backup at the time when the database instance is under load. With version update and patches, you may encounter compatibility issues. In that case, you should check the version specification and prepare the staging environment if necessary, to check the impact of the version upgrade and roll back if a problem occurs. And security issues include inappropriate security groups and missing IAM roles. And you are required to check the access by reviewing the security groups and assigning appropriate roles. Next, I'm going to introduce about the security. And you can use the VPC features and the security group for network isolation. You can encrypt data and communication, as well as the backup, storage, and logging. The RDS supports both data in transit and data at rest for encryption. And for authentication, you can use IAM for identity management. The command controls such as delete, update, and change, as well as the Kerberos authentication. And for encryption at rest, you can use AWS KMS. The encryption covers not only data, but also backups, snapshots, and log files. The primary instances and the read replicas are encrypted together. In other words, only the read replica or the primary instance cannot be encrypted. You can encrypt database instances only when you create the instance. If you want to encrypt the existing unencrypted instance, you must create the snapshot once, encrypt it when copying the snapshot, and then restore it. This procedure is frequently asked for the certification exam. And for encryption in transit, you can use the SSL certification. You can download the root certificate or bundled version from the console. At the time of this course release in 2023, you can use the RDS CA 2019, but it will expire in the August 2024. Previously, CAs has renewed every 4 years, but it is now valid CAs for 40 years or 100 years. And for authentication, you can use IAM like other services, and Aurora does as well. By IAM, you can eliminate to use ID and password, so eliminating the risk of password compromise and increasing the security. The command for using the token are described here. First, get token and connect to DB. The connection command differ for each database engine. And you can control access on a per table basis as well as on per instance basis. If you need to control the access on per table basis, you will use the commands by database engine. And here is a sample query for MySQL, and you can use the grant statement to grant the per table access privileges. Next, I will introduce Amazon Aurora. There are many common things with Amazon RDS introduced in the previous chapter, and in this section, I will focus on the Aurora's features. Amazon Aurora is a database engine developed by AWS. It is optimized for cloud-based applications. It was announced in 2014 and became generally available in 2015. Aurora is compatible with PostgreSQL and MySQL. It performs better than MySQL and PostgreSQL. Aurora has 99.99% service level and multi-region disaster recovery in less than a minute. And you can create up to 15 replicas to handle a large number of requests. It also delivers less than 10 millisecond processing latency for replicas in response to the request. Taking advantage of the cloud architecture, a single database can be operated across the multiple regions without performance concern. The Aurora is fully managed and supports the serverless architectures. The Aurora can scale from the 10 GB to 128 TB of the data volume. And I will introduce some of the features of Aurora's design. And first I will introduce the architecture of Aurora. For Aurora, you can manage your instances and storage separately. You can scale the computing and storage independently. Data volumes are stored in the 3 availability zones, 2 in each, for a total of 6, and this ensures the data redundancy. The Aurora follows the Quora model, which means that only 4 out of the 6 write operations and 3 out of the 6 read operations will succeed. In other words, if 2 out of the 6 write operations fail, the 4 successful data volume components each other to preserve the data. In Aurora, a read-write instance is called a primary instance and a read-only instance is called a replica. And you can create up to 15 read replicas. The volume on which Aurora data is stored is called the cluster volume. The cluster volumes are replicated to 3AZ for redundancy. The unit of primary instances, replicas, and the volume is called the cluster. And I will explain the Aurora's availability and failover. In the event of failure of the primary instance, the replica will be promoted to primary instance. In most cases, the recovery is in less than 60 seconds. In other words, in some cases, recovery may exceed 60 seconds. This recovery within 60 seconds is the best effort. If connected to the cluster endpoint, the endpoint is automatically switching during the failover, so you don't need to switch endpoint. If there are multiple replicas, you can assign the recovery priority. If no priority is set, or the priority is the same, the replica with the larger size will be promoted. If the new instance does not have the sufficient computing power and memory, the replica with sufficient capacity will be chosen because it will not be processed properly. This concept of the recovery priority is often shown in the exam test. And normally, during the failover, there is some downtime before recovery. By enabling the cluster cache, the cache is synchronized to the replicas and reducing the performance degradation during the failover. And the recovery time is often less than 16 seconds for Aurora, compared to 60 to 120 seconds for RDS, and less than 120 seconds for SLO. Next, the Aurora serverless is that you can use the Aurora in the serverless environment without preparing the instance. Since it is the serverless, CPU, memory, and any other computing resources are automatically scaled. The Aurora serverless manages the performance by increasing or decreasing ACU, Aurora Capacity Unit. The Aurora serverless are used when the frequency of the use increases or decreases, or when the frequency of the use is unpredictable. And with Query Editor, you can execute the SQL directly from the console. Currently, there are 2 versions of serverless, version 1 and version 2. And version 1 has been generally available in 2018, and version 2 is 2022. The differences between the 2 versions are listed here. The version 1 can be paused when not in use, and has no cost when not in use. And on the other hand, it takes longer to start up and is not suitable for application that needs to be up all the time. And version 2 is more performance and availability version. It operates at the minimum of 0.6 ACU, so it can be used all the time without warming up. And version 2 is more expensive. In terms of the certification exam, it is unlikely that the future of the version 2 will appear on the exam at this time, since it was released in 2022, but from the practical standpoint, it is better to keep in mind. And next, I will introduce the Aurora machine learning. By Aurora machine learning, you can use the machine learning model from the Aurora database. To learn Aurora machine learning, first you need to train your model in the SageMaker and deploy your endpoint. Then associate the necessary IAM role with Aurora and call the endpoint with a query from the Aurora. And you can seamlessly invoke machine learning model from the queries. And next, I will introduce the cost structure of Aurora. The Aurora's cost structure is basically equivalent to that of RDS introduced in the previous chapter. The Aurora's cost elements are instance, storage, and data transfer. The instance price vary depending on the instance type. On the other hand, Aurora Serverless, which does not have the fixed instance, charges per ACU. If ACU is not consumed, it is not charged, so you can optimize the cost according to the fluctuating demand. The Aurora's storage is automatically scaled, so you only pay for what you use. The RDS is charged for provisioned storage. And next, I'm going to introduce deployment and migration. Since there are many similarities with RDS, I will explain only the parts specific to Aurora. The Aurora supports MySQL and PostgreSQL, so you can use MySQL and PostgreSQL utility to migrate your data. When migrating to Aurora from on-premises or other cloud services, you can migrate via S3 bucket using utilities provided by Database Engine. And you can also migrate using RDS snapshot or promoting the lead replica. The migration via snapshot or lead replica are more efficient way and recommended over the migration using the MySQL dump or PZ dump. And this is a frequent question on the certification exam. When migrating from the Aurora to Aurora, you can migrate the data by creating a new Aurora DB cluster from the snapshot. And you can also migrate between the RDS and Aurora via snapshot and lead replicas. And you can take a snapshot of RDS-DB instance and migrate it to the Aurora DB cluster. And you can also promote a lead replica of RDS-DB instance and configure it as a new standalone Aurora DB cluster. And these migration methods for cases where the source and the destination are the same database engine, that is MySQL to MySQL or PostgreSQL to PostgreSQL. This will also be on the certification exam. If you are using a different database engine between the source and destination, you will migrate using AWS DMS. And you will also perform a schema conversion using the AWS SCT if needed. Next, I'm going to talk about the management and the operation. Here, I will explain the backup and the maintenance. Now, as for backups, the Aurora offers more extensive backup capabilities than RDS. And you can use the automatic backup for both RDS and Aurora. The Aurora provides the continuous backups, whereas RDS provides a daily backup. The point-in-time recovery is a feature that you can recover a database at any time within the 5 minutes. Then you can also clone your database instance, which copies the instance portion. With backtrack, you can rewind the database to any time within 72 hours. The backtrack is the rewinding the database to the point in time. The backups, the snapshot, and the point in time recovery restore the data to a specific point in time. With backtrack, you can rewind your database for up to 72 hours. With backtrack, you do not have to recreate the database, and the recovery time is shorter than with backup. However, in order to backtrack a database, you may have to temporarily stop the processing the database. The backtrack is now limited to MySQL compatible Aurora. The backtracking is used to restore a database to a specific point in time with the complete copy of the database at that point in time due to the disaster or other reason. The backtrack is the corrective measure for the short-term operational errors. The maintenance for Aurora is almost the same as for RDS. All you have to do is specify a maintenance window. The patching and the upgrades applies automatically. Zero downtime applies the patches with no downtime. However, this is the best effort and not all patches will be applied with a zero downtime. And next is the monitoring and troubleshooting. The Aurora and RDS have much common in the monitoring method, which includes the CloudWatch, extended monitoring, the performance insight. The Aurora also offers query-level monitoring via CloudWatch, extended monitoring, and performance insight. With fault insertion queries, you can test by intentionally inserting the fault. For example, you can simulate the instance crashes, disk failure, or I/O delays. Although the fault insertion query is the feature designed for testing, it is recommended that you test it without the production data in it. The database activity streams database activity for DML and DDL in real time. And you can integrate the stream with the Kinesis data firehose and the CloudWatch event. And finally, I will talk about the security. The Aurora's security features have much common with RDS, including the networking such as VPC and firewalls, encryption during the communication and storage, and authentication through the IAM, as described in the RDS chapter. The Aurora also offers the advanced auditing, which provides details about information. The advanced auditing provides a history of SQL level audit information, such as DML and DDL. And you can filter auditing information based on the user, IP addresses, database, and the table. And next I will introduce Amazon Redshift. The Amazon Redshift is a fully managed data warehouse service that can store and analyze the petabytes of data. It provides the high computing power with low latency for big data analysis and business reporting. A Redshift is highly scalable, so you can store and analyze data ranging from the terabyte to petabyte. It's cost-effective, and you don't have to pay upfront cost, and it's pay-as-you-go system. And fast query execution using the columnar storage, the data compression, and the distributed execution. For security, Redshift provides a high security through the deployment, encryption, and access control within the VPC. The AWS automatically performs the operational tasks such as backups, patching, and the recovery from node failure. And you can easily integrate with other AWS services such as S3, RDS, and DynamoDB. And also, you can use the standard SQL base so that you don't have to learn new language for data analytics. A Redshift is one of the most important analytical tools in the context of the data analysis. Firstly, I'm going to explain the database design. This is the architecture of Redshift. The architecture is composed of a collection of nodes referred to as a cluster. And within a cluster, there are two types of node, leader node and compute node. The leader node manages the query coordination and directing the query to appropriate compute node. When a query is issued Redshift, the leader node passes and develops an execution plan to carry out the query. It then coordinates the compute node to run the query in parallel. The leader nodes also manage the distribution of data among compute nodes. On the other hand, the compute node stores the data and executes query components that the leader nodes assign. Each compute node has its local storage and operates in the parallel with one another. The data within the compute node is organized into the slices. Each slice is essentially a portion of the node storage, and each slices processes a portion of the query. The number of the slices is determined by the node type of the Redshift cluster. I will introduce the node type of the Redshift. The DC, the dense compute, provides the SSD-based storage and has compute-intensive performance. It is suitable for the data volume less than the 2 TB for maximizing the query performance. DS, the dense storage, provides the HDD-based storage and is an option for storing the large amounts of data. DS is suitable when you need to store large amounts of data and want to minimize the storage cost. And for RA3, a managed storage that provides a cost-effective storage by SSD to provide a high performance while simultaneously storing the data on S3. The hot data will be kept on the local SSD storage, while the cold data is offloaded to S3. The RA3 is ideal for the scenario where the flexible storage solution is required, such as when data is very large or data growth is unpredictable. In data warehouse that process big data, high-speed, parallel dispute processing is used. This is called the MPP, the massively parallel processing. MPP database uses the distributed system to process data and execute database queries in the parallel across the multiple nodes. The MPP system breaks down the task into the smaller subtasks and distributes them to compute nodes to be processed concurrently. And this parallelism accelerates the query performance, especially on the large dataset. The Redshift supports the 3 types of distribution: key, even, and all. I will explain the detail of the keys in the next page. In Amazon Redshift, the tables are distributed across nodes for paralleling the processing. There are 3 types of data distribution: key, even, and all. and which are automatically determined through the machine learning. With a key distribution, rows are distributed across slices based on the value of the one column, which is called as the distribution key. And this is beneficial when the frequently joining a table on the distribution keys, as Redshift can perform local joins within the node without shuffling the data between them, enhancing the query performance. In all distributions, a copy of the entire table is distributed to all nodes. This allows for the local join with the table within node. It is useful for relatively small lookup tables that are frequently joined with larger tables. However, replicating the entire table on each node consumes more storage. The even distribution disperses the row across the slices in the round-robin fashion without considering the value of any specific column. It is the default setting and is effective when the tables are not involved in the join, ensuring the even distribution of data. Using the example table, I will explain the use case for different distribution styles. For example, there is a customer table and an order table. The customer table contains the customer ID, customer name, a customer email, and has a relatively small number of the records, about 1,000 rows. It acts much like a master table. The order table includes the order ID, customer ID, the product ID, and the order date, and has a large number of records which continue to increase with the transaction. When joining these tables on the consumer ID as a key, rows with the same customer IDs are placed in the same slice, resulting in the faster joining operation. This serves as an example of the key distribution style. Next is the all distribution style. Since the customer table is the master table and small inside, it can be distributed by all. This means the customer table gets copies across each slices. When performing the operation like joins, there is no need to move data between it and the other table. On the other hand, as the order table is the transaction table, which grows inside with the transaction, distributing it with all would take time-consuming for copying. So, also the overall capacity increases, which can put a strain on the cost. So generally, it is not recommended that the transaction table as all. When there is no need to distribute based on the specific key and the table size is not so large, you can distribute the rows evenly in the round-robin fashion. And this is how you differentiate between the distribution style. Next, Elastic Resize is designed for quickly adding or removing the node in a Redshift cluster, allowing for the fluid adaptation to workload demand. During the resizing, the cluster becomes a temporary read-only. However, the returning to the writable state is quicker compared to normal scaling up. It's handy when you can predict a workload increase and needs a temporary boost in capacity. The concurrency scaling handles the simultaneous processing by offloading read queries, or what's called a transient cluster. And this ensures the consistent performance even when a large number of the query hits at the same time. It's really useful when you cannot predict when those simultaneous read queries will happen. And Again, ROS3 instance is instance type optimized for Redshift. By using the ROS3 instance, you can separate the compute from storage, which let you adjust the size of the cluster based on the compute scaling and scale storage independently. And Redshift uses a shared nothing architecture. In shared nothing, each node works by itself and keeps part of the full dataset in its own storage. And this setup spreads out the data across the different nodes, which helps do many tasks and at the same time when running the queries. A leader node manages the running of the queries and gather the answers from the other compute nodes to give the final result back to the user. In this way, Redshift can do many tasks at once across all nodes. The opposite component of the shared nothing is known as the shared storage. With shared storage, the cluster nodes share the use of the one storage area. And next I'm going to introduce the Redshift Spectrum. A Redshift Spectrum is one of the Redshift's most important features. With the Spectrum, you can execute a query directly on the data stored in S3 without any loading or ETL. You can work with the exabytes of data directly in S3. It is cost-effective because you only pay for the queries you execute, and there are no initial cost or no commitment. The Redshift Spectrum integrates with AWS Guru, allowing you to explore and catalog your data schemas. I'm going to introduce the use case for Redshift Spectrum. With Redshift Spectrum, you can separate your hot data from your cold data, and you can optimize cost by keeping frequently accessed data in a Redshift cluster and storing the less frequently accessed data in S3. And you can also archive your infrequently accessed data with S3's lifecycle management. You can query large amount of data directly on S3 with Redshift Spectrum. It takes a lot of time to copy large amount of data from S3 to Redshift, so you can save the loading time by querying the data on S3 directly from Redshift. And you can also combine dataset on the Redshift and S3. And next I will present the best practice for Redshift Spectrum. And you can reduce the amount of scanning data by unifying the format in S3 with a column-oriented format. And you can improve the query performance by splitting a large file into multiple smaller files. It can be more efficient for you to query S3 packet if they are tailored to the filters criteria of the query. For example, if you create the bucket by date, it's more efficient if you run your query by date. And you need to keep statics up to date. Since Redshift charges by amount of scans, it's better for you to reduce the amount of scans. Next, I will introduce the management and operation. Here I will introduce the Redshift command and their best practice. And I will explain the key command in Redshift and their best practices. And first, the copy command is used to rapidly load data from the data sources such as S3 and DynamoDB into Redshift table. The Redshift copy command is designed to highly parallel. It automatically divides the data among all compute nodes in the cluster and loads them in parallel. resulting in the high throughput and efficient resources utilization. And you can also copy file in parallel by specifying the multiple file in your manifest file. And you should use the appropriate file format. Just check the data type and format in advance. And it is recommended for you to use a compressed file to optimize the performance. A join is an operation that joins two or more tables based on the key columns. And you should specify the dist key to optimize the distribution of the data over key columns. And you should also make sure the join key is you often use as up-to-date with statics. In this case, statics means, for example, maximum and minimum values, average values, and so on. And insert is an operation that adds new records to table. And notice, if you are inserting a large amount of data at once, it is more efficient to use the copy command. In other words, inserting a large amount of data is not recommended. You should also insert data paying attention to tables constraints, such as the index and the key constraints. The vacuum collects the unused space in the table and rearranges the data. In Redshift, fragmentation occurs after delete or update, so use the vacuum to defragment. Since the delete and update in Redshift are actually logical deletion, so it is recommended that periodically vacuum be performed to collect space. And if you perform delete or update frequently, you should periodically vacuum. And the vacuum is resource intensive and should be performed during the low traffic times. The vacuum delete only, the vacuum sort only, and the other types of vacuum as needed. The analyze is a command that updates table statics. The statics are used by the Redshift query planner to improve query performance. It is recommended that analyze be run after major changes to data have been made, especially after large data loads, deletes, and update. The update is a command that updates the existing record. As I have repeatedly explained, in Redshift, update operation takes the form of logically deletion existing rows and adding new rows, and which can lead to fragmentation when performing the large number of updates. You should do the vacuum run if you do a frequent update. In Redshift, each workload is managed by queue. Each queue has dedicated memory and a fixed number of query slots. When SQA, Short Query Accelerator, is enabled, Redshift uses a dedicated memory queue for the queries that are executed in the short period of time. This short query queue is added to the WLM queue and executed ahead of the time. The SQA reduces the response time and simplifies the workload. And next, I'm gonna introduce security feature of Redshift. Like other database service, Redshift provides encryption for data storage, network security with VPC, and logging and trade function. And you can control access to Redshift tables, database, schemas, the per function access control, and the per column access control for table views. In Redshift, you cannot directly encrypt the unencrypted cluster. Instead, you should create a new encrypted cluster and migrate data to new cluster. This method is similar to Amazon EBS and Amazon EFS. To encrypt the unencrypted EBS volume, you will need to create the snapshot of the volume and copy the snapshot with encryption enabled and create a new encrypted volume from that snapshot. If we want to encrypt the unencrypted ESF file, create the new encrypted EFS file system and copy the data. And next, I will introduce DynamoDB. Amazon DynamoDB is a free managed NoSQL database service. It provides high availability, reliability, and scalability, and is used for large distributed application and microservice architecture. DynamoDB is the original AWS NoSQL service and is used for a wide range of applications. Along with the RDS and Aurora, it is the one of the most frequently shown up on the certification exam. DynamoDB is a free managed service. It is serverless and you don't need to manage the infrastructure. DynamoDB is a key value database which is characterized by its simple and flexible structure. DynamoDB offers the high scalability. It is serverless and can handle high traffic by automatically scaling as traffic increases or decreases. It provides the fast performance and delivers a millisecond latency and normal condition. And with DynamoDB Accelerator, the latency is in the microsecond range. DynamoDB provides the automatic replication of data across the multiple regions with global tables. DynamoDB provides the security features such as data encryption, access control, and auditing. With DynamoDB streams, you can capture table changes and process them in real time. And it provides the ability to get full backups on demand and restore data at the specific point in time. Firstly, I'm going to introduce the design feature of DynamoDB. Here I will explain the capacity mode, how to set key and secondary indexes, DynamoDB streams, DynamoDB Accelerator, and the global table. First off is the pricing plan and the capacity mode of DynamoDB. There are two types of the DynamoDB capacity mode, on-demand and provisioned capacity mode. In on-demand mode, capacity is increased and decreased in response to the request. On the other hand, the provisioned mode is used when you can estimate the amount of requests in advance. Here is the table, the comparison the read and write for each capacity mode. In on-demand mode, 1 kilobyte write operation are considered 1 unit and charged at the rate per million operation. In read processing, 1 million read with 4 kilobyte stroke consistency or 2 million read with 4 kilobyte the eventual consistency are charged as 1 unit. In provisioning mode, the billing is based on the WCUs, write capacity unit, and the RCU, read capacity unit. Now I will introduce the calculation of capacity unit again on the next page. At DynamoDB, the billing unit price vary by the region. The provisioned capacity mode is more suitable in the situation that you have continuous requests, while the on-demand mode is more suitable when requests are fluctuated. In provisioned capacity mode, RCUs and WCUs can be purchased as the reserved capacity. The reservation period is 1 year or 3 years. And here is an example of the unit calculation. Assume we are processing at 4 kilobyte items. A read with the strong consistency consumes 1 RCU. The read with the eventual consistency consumes 0.5, and the transaction consumes 2 RCU. The writes consumes 4 WCU, and the transaction processing consumes doubles 8. And by the way, there is no strong consistency in write operation. When using the provision capacity mode, WCU and RCU can be scaled automatically. The auto-scaling in DynamoDB, you can set the utilization, minimum and maximum values for capacity unit. The image on the left is what it looks like when the auto-scale is not set. The red line is the provisioned capacity unit, and the blue area is the actually consumed capacity unit. If auto-scale is not set, the extra capacity units are provisioned when the number of capacity units actually consumed is low. Conversely, if the amount of capacity units consumed increased and exceeded 80%, the provisioned capacity unit, DynamoDB processing may be affected. On the other hand, the image on the right is what it looks like when the auto-scale is enabled. You can see that as the blue increases, the provisioned capacity unit is increased. Conversely, as consumption decreases, the provisioning amount also decreases, and which provides the necessary and sufficient capacity unit for optimal cost performance. On the other hand, it may not be able to keep up with a sudden spike in request. So if a sudden spike in the request is anticipated, it is necessary to provision capacity unit with a sufficient margin. Next, I will introduce the cost of DynamoDB. Similar to the database service introduced so far, the DynamoDB charges for read and write request, data storage, and data transfer. And I will explain the DynamoDB specific cost on the next page. Backup and restore is charged per gigabyte, and point-in-time recovery is charged per gigabyte and per month based on the table size. And there is also a per gigabyte charge for exporting to S3. The automatic backup are also charged per gigabyte per month. The restore are also charged based on the size of the data to be restored. The global table replication is charged per replicate write request. The billing unit differs between the on-demand and provisioned mode. In on-demand mode, 1 million write requests are charged as the 1 unit. In provision mode, the charge is based on the write capacity unit. On the other hand, read request and the storage for global tables are built along with the original table. This is because the write process requires processing to be consistent across the globally distributed table, while the read process reads data from one of the tables. The change data capture is the ability to send the DynamoDB change data to Kinesis data streams or GRUE Elastic View. The change data capture is charged per million change data capture unit with a maximum of 1 kilobyte write as one change data capture unit. A DynamoDB accelerator charges by the hour per hour. The unit price depends on the instance type. And the DynamoDB stream is charged per 100,000 streams read as one read request unit for each get record API call. I will explain the DynamoDB accelerator and the DynamoDB streams again on later pages. A DynamoDB cost structure is very unique. Next, I'm going to introduce keys and secondary indexes. I'm going to introduce you to the partition keys of DynamoDB. In DynamoDB, data is distributed across the multiple partitions. A partition is the storage area allocated on SSDs actually. By distributing the data evenly through partitioning, you can improve the performance. Conversely, the biased partitioning can result in poor performance. Since partition capacity management and multi-AZ replication are managed, you don't need to worry about it. However, you need to select the key by yourself. This is the table that consists of order ID, the product name, the price, the quantity, and the date. We assume that user will research for the order information using the order ID as a key, and therefore we will set the order ID as the partition key. The partition key can be thought of as the primary key. The data on the DynamoDB table is distributed based on the partition key. Next, a sort key is the further sorting by attribute within the partition. It can be used as the composite primary key to accompany the partition key. In the same table as before, we set the order ID as the partition key and the product name as the sort key. The table will be distributed by the partition key. And furthermore, within the distributed table, the table is rearranged by the sort key. You can then efficiently search by order ID and the product name as the composite key. In the DynamoDB table, the hash value of the partition key value determines the partition that will be distributed. And you should design the partition to be random value so that access will be distributed. If you're gonna use the regular or sequential value as keys, such as the date or item numbers, accesses may be concentrated on the certain partition, which will worsen the performance. When specifying the partition key, you can help balance access by sufficing or setting the random value to partition key. Next, I will introduce the secondary indexes. In a key-value database, you can improve the searchability within the table by adding indexes. There are two types of secondary index: local secondary index, where the search is completed in the same partition as the original table, and the global secondary index, which are created using an attribute different from the primary key. Since the global secondary indexes uses a different attribute, you can set it after you have created the original table. On the other hand, for local secondary index, you must set it when you create the table. For key-value database, it is not recommended to use indexes extensively, since the single primary key enhances the searchability of the database. And moreover, the heavy use of the indexes affects the data capacity and cost. So if your use cases require heavy use of indexes, you should consider switching to RDB, not to use DynamoDB. The AWS best practice also recommends that only the data of the same nature be placed in the one table. I will introduce the local secondary index. We have the table with the order ID as partition key and the product name as sort key. And you can improve the query performance by setting the order ID as the primary key and the product name as the sorting key. In this case, it is assumed that the user will frequently searching using the order ID and the product name as the keys. In the local secondary index, you set a different sort key than the original sort key. The partition keys remain the same. For example, if you specify the purchase date as the local secondary keys, you sort by purchase date. And in this case, it is assumed that the user will have a need to execute a query with the purchase date as the key, not just a product name. Then I will show you some tips on setting up the local secondary indexes. The total size of the indexes in the table per partition key is limited to 10 GB. If exceeded, an item collection size limit exceeded exception error will be returned. If the partition keys are biased, some indexes will become too large, resulting in one error. The partition key must be set so that there is no bias in the size of each partition. And when writing, more WCUs are consumed as you write to the local secondary indexes. In general, it is a trade-off between storage and performance, so you should balance between the searchability and the cost when setting the secondary index. And you can set the local secondary indexes only when you create a table. In other words, you cannot add or delete local secondary index for existing table. To add a local secondary index to an existing table, and once make a backup and see it when restoring from the backup. And next, I will introduce the global secondary index. Consider the same table as before with the order ID as the partition key and the product name as the sorting key. In the global secondary index, we set a different partition key and sort key than original partition key and sort key. In this example, we have set the product name as the new partition key and the purchase date as the sorting key. A global secondary index is beneficial when users query based on the different attribute. Unlike the local secondary index, you can set a global secondary index even after you have created a table, since a global secondary index set a new partition key and sort key. The disadvantage of adding the secondary index includes the performance impact, storage cost, and read cost. As for performance impact, when you write to a table, you must also update the associated index. Therefore, if there are multiple secondary indexes, write costs tend to be higher. As for storage cost, having secondary indexes consume more storage. Creating the secondary index means storing another copy or subset of data. As for read cost, the reading from the secondary index consumes the RCUs. The secondary indexes speed up the query operations that require full table scans but incur the read cost. And so far, I have introduced the characteristics and the disadvantage of the secondary indexes. In actual practice, you need to design your indexes while taking into account overall cost and functionality. This is because cost and functionality are trade-off. For some use cases, a relational database may be more cost-effective than key-value database such as DynamoDB. Next, I'm going to introduce DynamoDB streams. A DynamoDB streams is a function which captures a time-ordered sequence of item-level changes in any DynamoDB table and stores the changes for 24 hours. It captures a record of changes to items, insert, update, and delete. A DynamoDB streams includes a record and shard ID. You can use the streams to replicate the item-level data from one table to another across the AWS region. You can also analyze the date changes and feed them into the other systems such as Amazon Redshift or AWS Lambda. And with AWS Lambda, the process that changes data and sends a notification whenever item is changed in your table. With the DynamoDB streams enabled, you can use global tables. Next up is DynamoDB Accelerator. A DynamoDB Accelerator, or DAX, is a cache strategy which is designed to improve the read performance, offering the microsecond responses times for accessing your data. A DAX makes read performance faster for heavy read workloads. The DAX improves the DynamoDB read performance by up to 10 times, even at the millions of requests per second. A DAX is an in-memory caching, which means it keeps frequently accessed data in RAM, reducing the need to access the original table. A DAX takes a write-through strategy. When you write to a table, the DAX writes both to the cache and the DynamoDB. And for read operation, the DAX first accesses the cache, and if it finds the data, it returns it. And if there is not the cache, it fetches the data from the original table and caches for the future request. Now I will describe the behavior of the DAX. And for request from the application, if there is a cache in the cache layer, the response is returned from the cache. On the other hand, if there is no cache in the cache layer, the request is forwarded to DynamoDB table. And you can set the time to live for the cache. The default is 5 minutes. Therefore, you may not get the latest data of the original table. If you request with the strong consistent read, the response is directly returned from the original table, not DAX. When you send the write request, the request writes to both cache and the DynamoDB table. This is called the write-through strategy. And if both writes succeeded, a success response is returned. Next up is global table. A DynamoDB's global table lets you make copies of a table in any region, and this is called the multi-master. It means if you change one table, all other table updates the same way. You need the DynamoDB streams enabled to use global table. DynamoDB streams make sure that when you write data, it stays the same in all tables. The reading are faster because of the special cache. You need the auto-scaling enable or set the on-demand capacity for writing data to use the global table. All tables in different regions must have the same name, write capacity, encryption, time to live, and global secondary index setting. Next, I'm going to introduce the management and operation. Here I will explain the operation of DynamoDB and backups. The first one is operation. I'm going to explain about the writing and the reading in DynamoDB, as well as about the eventual consistency and the strong consistency. When you send a write item request, the DynamoDB writes the data a specific partition. This data is usually replicated within 1 second across table in the 3 availability zones. And this ensures the eventual consistency among the 3 AZ. The eventual consistency means that the final result of the data is guaranteed to be consistent, but the consistency during the replication is not guaranteed. Therefore, when performing the read item, there may be a time lag, the meaning that the process has not been reflected in some AZ. A DynamoDB supports a read request with strong consistency. And when you make a read request with the strong consistency, it returns the value only after all the data has been reflected. This means that there is a possibility of an error being the return if the data is the process of being reflected. Consequently, the read request with the strong consistency tends to have a higher latency compared to those with the eventual consistency. Moreover, compared to eventual consistency, there is a larger consumption of the throughput. In the case of global index, the read requests with the strong consistency are not supported. Now I'm going to introduce some APIs of DynamoDB. The first, here is the difference of the query and scan. The query is retrieving a specific item based on some conditions, and it returns an array of items. While the scan is retrieves the entire table and return all the data. It is recommended to opt for query instead of the scan in terms of performance, because scanning the all table item can be time-consuming. If you scan, it recommends to filter only necessary data. The maximum response size for both query and scan is 1 MB. If the result exceeds the size, it will be paginated. Next, differences between batch and transaction. In DynamoDB, the batch method is particularly useful for the writing and reading large amount of data. And you can use the batch write item and the batch get item to execute a parallel processing. The batch processing continues until completion even it fails. Any items that fail to write or read are recorded as unprocessed items. On the other hand, the transaction allows all or nothing principle, which means that if any part of the transaction fails, the entire transaction will be rolled back and failed. And you can make the entire database consistent with the transaction. For example, let's take a hotel reservation system. When the multiple reservation requests are sent for a room, the transaction should be a fail because the double booking will occur. Next, I'm going to explain backups. The DynamoDB backup includes the on-demand backup and point-in-time recovery. The on-demand backups are the backups that perform at any time, and regardless of the size, it can be restored in seconds, so there is no performance impact. The backups remain until you delete them. The backup is saved even if the original table is deleted. The point-in-time recovery can save it for up to 35 days. You can retrieve and restore transaction logs every 5 minutes. Therefore, the point-in-time that can be restored is from the 35 days ago to 5 minutes ago. The point-in-time recovery is reset once it is disabled. For both on-demand backups and point-in-time recovery, the new tables are created when you restore. In other words, you cannot restore to an existing table. When restoring, you can configure the secondary indexes, the capacity mode, the capacity units, and encryption. Additionally, auto-scaling, IAM policy, CloudWatch, tags, stream setting, and TTL will need to be configured after the restoration if necessary. Next, I will introduce the monitoring and troubleshooting. The first one is monitoring. For DynamoDB, like any other database service, you can monitor it with a CloudWatch. A DynamoDB is a free managed service, so you don't have to manage any layer below the server. You need to monitor table performance and do capacity planning appropriately. And this table shows some example of metrics that can be get with any DynamoDB. The DynamoDB uses the capacity units to manage performance, so you need to monitor each write and read capacity unit. And if necessary, you will need to adjust the capacity unit provisioning. And you can also tune performance by monitoring throttling, error occurs, and number of items returned by scans, and latency. And with CloudTrail, you can record API call to DynamoDB, and then you can retrieve management event and data events. The management event includes the creating and updating table, replicas, and creating the backups. The data event records API calls made to items in the table, such as get, put, update, delete, and so on. The next one is troubleshooting. I'm going to introduce some common troubleshooting for DynamoDB. From above, the performance issued includes a high latency and a delayed read and write operation. The workaround in this case includes increased the provision throughput, the distributing the hotkeys, and using the DynamoDB accelerator. And throttling issue is the provision throughput exceeded exception errors, and errors that occur when the provision throughput exceeds the limit. In this case, you can adjust the throughput, adjust the key distribution, use batch operation to reduce the number of requests, and configure auto-scaling. And as a capacity planning, the countermeasures against the problem that may result in the unexpected charges includes the monitoring and adjusting capacity units, and considering the on-demand capacity mode. Overall, by setting the capacity mode, key design, and auto-scaling, you may be able to resolve these issues. When it comes to security, it's like any other database service. The strategies to ensure the data consistency includes using the strongly consistent read and using the transaction rather than batches. When it comes to the application integration, you had better to use AWS SDK and enable DynamoDB streams. And these troubleshooting are deeply related to the DynamoDB's unique table design and capacity mode. Again, the DynamoDB is a free managed service and serverless, so you don't have to manage any infrastructure or servers. On the other hand, table design is important because you are responsible for the managing the capacity unit, capacity mode, and the key settings. Next, I'm going to introduce the security. For DynamoDB security, like any other database services, it includes the IAM access control, encryption, and network isolation. Here I will introduce things specific to the DynamoDB. A DynamoDB allows access control using IAM. And not only table, but also indexes and streams have the unique ARNs, so access can be managed accordingly. This is a sample of IAM policy allowing the action on DynamoDB table. And usually, action on DynamoDB table are executed through APIs. You can control access to DynamoDB by IAM. And regarding the networking, you can use DynamoDB's gateway VPC endpoint. The gateway endpoint, you can use the S3 and the DynamoDB. Here is the comparison table the differences between the interface endpoint and the gateway endpoint. The gateway endpoint uses the routing table, so all you have to do is add and enter the routing table. And you can manage the DynamoDB with one endpoint, which simplifies the configuration. And next, I will introduce the Amazon ElastiCache. The Amazon ElastiCache is a managed caching service which allows you to deploy, operate, and scale an in-memory cache in the cloud seamlessly. ElastiCache is the managed service which automatically manages the administrative tasks like hardware and software provisioning, setup and configuration, patching of the software, and monitoring. ElastiCache support for Redis and Memcached, which I will introduce in the following page. With ElastiCache, you can start with the small cache instances, and then scale up to a larger instance, or partition your data across the multiple cache instances. ElastiCache for Redis support multi-AZ deployment, which enhances the availability by allowing the automatic failover in the event of the primary node failure. ElastiCache has a cluster mode which enables high scalability and availability. The use cases of the ElastiCache includes the database caching, the session store, real-time analytics, the message brokering. It's especially beneficial for the read-heavy or compute-intensive applications. Firstly, I will introduce the database design. I'm going to introduce the Redis and Memcached and the cost structure of ElastiCache. The first one is the differences between Redis and Memcached. Redis and Memcached are popular third-party in-memory stores. The ElastiCache support both Redis and Memcached. The difference between the Redis and the Memcached are shown in this comparison table. Redis supports more data types and supports availability, redundancy, and data persistencies, whereas Memcached has the simpler data types and it's multi-threaded, which improves the per-node performance. The Memcached is a multi-thread, so it has the advantage of being easy to scale horizontally, whereas the Redis is single-threaded. However, the latest version of Redis also supports multi-threading. The Redis, on the other hand, is highly fault-tolerant because it creates a read replica across the availability zone and failover in the event of the failure. And Redis also has the data persistence, so it can also be used as a primary data store. Overall, the Redis has more features, while the Memcached is characterized by its simple configuration and high performance. And next, I'm going to introduce the ElastiCache for Memcached. I will introduce the architecture of the Memcached. The Memcached has the structure with multiple nodes in the unit called the cluster. The number of the nodes ranges from 1 to 20 per cluster. The node failure in the cluster are automatically detected and replaced. On the other hand, when the client accesses a node, the user explicitly selects it from the list of the node. ElastiCache does not automatically manage the connections. For example, you can get the node information from the CLI by typing describe the command like this. You access the appropriate node from the list the node obtained there. The ElastiCache has an endpoint for each node, so you need to manage the connection every time you scale out or in. AWS SDK supports memcached client with auto-discovery that periodically retrieve the endpoint, which you don't need to detect the endpoint. On the contrary, the memcached for Redis has the ability to manage the connection endpoint automatically. For ElastiCache, to increase the processing performance, you need to increase the node type or scale up. ElastiCache is an in-memory store and does not persist the data within the nodes. So when you create a new cluster, you just connect to a different endpoint. And next I'm going to introduce the ElastiCache for Redis. First, I will introduce the structure of the ElastiCache for Redis. A Redis consists of the node group that are made up of the multiple nodes. A shard contains the primary nodes and the replicas. The replicas are read-only. You can set 0 to 5 replicas. The ElastiCache for Redis has endpoints for each cluster, shard, and node. However, the cluster manages the reading and writing to the node, so you typically use the cluster endpoint. Once you connect to the cluster endpoint, it automatically determines which node to connect to, so you don't have to manage it. By the way, the node endpoints are often used for maintenance to each node. You can configure cluster mode in Redis. When you disable the cluster mode, it becomes the single node, and the ElastiCache has no redundancy. When you enable cluster mode, you can use multi-node, and each ElastiCache divides in the data into up to 500 nodes. And the ElastiCache divides your data into up to 500 nodes. The ElastiCache has a maximum of 500 nodes when a shard has only one primary node. If you have a primary node with one shard and 5 replicas, or 6 nodes per shard, the number of the shard is the 83. So the 6 times 83, you can add up to 498 nodes. This comparison table shows the future which cluster mode is enabled or disabled. By disabling the cluster mode, you can use only a single node. And you can still create the read replica even if you disable cluster mode. So you can promote a read replica in the failover configuration in the event of the failure. The performance is limited to a single mode. If a cluster mode is enabled, you can create up to 500 nodes. Data is partitioned across multiple nodes. However, because the data is partitioned across the multiple nodes, and backup and restore tend to take a longer time. In terms of performance, enabling the cluster mode will increase the throughput due to the load balancing. When using a larger dataset, you should enable cluster mode. I would like to introduce the scaling of Redis. If cluster mode is disabled, that is, if the node group is the singular, you have only one primary node. So if you want to improve the performance, you must change the node type. That means you can scale up and improve the performance. You can scale immediately or during the maintenance window. You can add and remove replica nodes from the console or CLI. If cluster mode is enabled with multiple node groups, you can scale horizontally and vertically. In other words, you can add and remove the shard and change node type. With Memcached, you are required to select a node, whereas the Redis automatically distributes when you scale out. You don't need to worry about which node they connect to. Next, I'm going to introduce to the global data store. For Redis, you can create a cluster in different regions. You can create one primary region and up to 2 secondary regions. The primary region is a read and write. The use case for the global data store includes the primary region failure, handling and improving the performance through the geographic proximity. However, you must perform a failover manually. These are the tips for the global data store. The Redis version 5.0.6 or higher is required. Also, the node version must be R5 or M5 or later. The global data store is available only in the open source edition of the Redis. The primary and secondary have the same configuration. Additionally, some features may not be available on the global data store, and there may be a latency in replication between regions. Next, I'm going to introduce the cost structure of ElastiCache for Redis. ElastiCache cost element includes the price of node, the cost of the data transfer, and the changes for backup storage. Regarding the node cost, you are charged per hour depending on the instance size. The reserved nodes offer reservation made for 1 or 3 years. Additional payment discounts apply. For data transfer, you will only be charged outbound. You are charged per gigabyte. The backup storage provides 1 free snapshot per Redis cluster. If you take additional backups beyond the free snapshot, you will be charged per gigabyte. Next, I'm going to introduce the management and operation. The upgrades for operation system require a reboot. The rebooting occurs automatically during the maintenance windows. A parameter group is a set of configurable items, and this includes the timeout values, memory, logging level, and many other items. And also, Redis and Memcached each have the default parameter groups, and you cannot customize the default parameter groups. I'm going to introduce the backups for ElastiCache. Redis supports backups. You can take a backup on the entire cluster and save it to the S3 as an RDB file. Redis supports automatic backup and the manual backup once a day. The manual backup can be created up to 20 per node at any time in 24-hour period. The Redis has a data persistence option called AOF, Append Only Files. The AOF is a function to get logs for all write operations and redo these logs to restore the database state. You can customize the configuration file. The tips for AOF: if you set append sync to always, there's going to be more time to synchronize get AOF, which can result in a higher write latency. In ElastiCache, data is volatile, and by failover, AOF file itself will be vanished. So rather than restoring using the AOF file, AWS recommends using the cluster with the multi-AZ enabled for redundancy. And next, I will explain the monitoring and the troubleshooting. You can use CloudWatch to monitor ElastiCache just like any other database service. Since ElastiCache is an in-memory store, the cache hit rate and the cache missing are unique metrics. If cache misses occur frequently, and next I will explain the monitoring and the troubleshooting. You can use CloudWatch to monitor ElastiCache just like any other database service. Since ElastiCache is an in-memory store, the cache hit rate and the cache missing rate are unique metrics. If cache misses occur frequently, you may need to increase the cache retention period. And this is a table of common ElastiCache issues and the troubleshooting. As I mentioned earlier, the Redis has an excellent scale-up and backup capability, so you may experience latency and performance issues across the multiple shards. Lastly, I'm going to introduce security. The ElastiCache supports encryption in transit and at rest. However, you can only use Redis 3.2.6 and 4.0.10 or newer versions. The encryption at rest uses the KMS and the default encryption keys. For authentication, the Redis-specific features include the password authentication using the Redis Auth, and the role-based access management is supported, starting with the Redis 6. The ElastiCache cluster are created within the VPC. The cluster knows the assigned CIDR ranges, so you can use security table and network ACLs. Next, I will introduce the Amazon DocumentDB. Amazon DocumentDB is a free managed document database that is compatible with the MongoDB. It's suitable for applications such as web and mobile and IoT that handle a large dataset. By separating the read and write workload, it enhances the scalability and performance. Additionally, creating extra replicas further boosts read scalability. The data is replicated on the AWS storage, ensuring the data durability and availability. It also supports the multi-AZ deployment, allowing for automatic recovery from failures. And you can migrate MongoDB application to DocumentDB without modification. And moreover, you can interact DocumentDB with using the MongoDB API. And you can leverage the AWS security feature such as network isolation, encryption, and access management, and ensure the safety of the data. So I will explain the database design first. And firstly, I'm going to introduce what the document database is and the MongoDB. I'm going to introduce the MongoDB. The MongoDB is a document-oriented database. A document database in JSON-like format that provides a flexible hierarchical structure. This is a sample document, and the name and the address are listed. And the address includes the street and the zip. That is, the address is the parent hierarchy, and the street and the zip are the children. The MongoDB also has excellent scalability that supports rich queries and is highly available. DocumentDB is currently compatible with the MongoDB version 3.6 and 4.0 and 5.0, but you may not have access to the all features. They're compatible with MongoDB, so you can use the MongoDB's APIs and seamlessly migrate your existing MongoDB application to AWS. This is a list of features supported by MongoDB version 4 and 5 and DocumentDB. The DocumentDB supports some features of MongoDB. The certification exam does not ask questions in such detail, so it is not necessary to memorize every item in order to prepare for the exam. The document databases are flexible and scalable and are used in the content management system, real-time analytics, mobile, web application, catalog, and more. The document databases are schemaless and flexible compared to RDBs. The RDBs require data types and digits to be defined, but the DocumentDB do not. Therefore, it is useful in cases such as those listed here where the data format changes. And also, compared to key-value type database, the DocumentDB can have the hierarchical structure and the multiple attributes. And here we have the sample data and queries for DocumentDB. In this sample, the database called books contains the information such as book title and authors. Although it contains the strings and the numbers, you don't need to define the data format or digit in advance. And also, the single item can have the multiple attributes. Then also, we have sample query of the find, update, and remove. And you can specify database item to execute flexible queries. And next, I'm going to introduce the structure of DocumentDB. And this is the configuration of DocumentDB. The DocumentDB consists of the 0 to 16 DB instances. You can configure one primary read and write instances and up to 15 read replicas. And you can have the total of 6 cluster volumes that corresponds to your DB instances across 3 AZ. And this structure is similar to Amazon Aurora. And the storage size is up to 128 TB. Because the DocumentDB instance is deployed in the VPC, you can use the network security such as security groups. The DocumentDB is a multi-AZ and provides high availability even during the failures. If the primary instance fails, the one of the read replica is automatically promoted to primary. If you have a configured cluster endpoint, DocumentDB automatically switches endpoint during the failover. And next I'm going to explain the Elastic Cluster, which is generally available in 2022. It provides the scaling elastically, which means it performs millions of read and write per second, and it has the petabytes of the storage capacity. There are some functional limitations when using Elastic Cluster. For example, you cannot change global cluster, performance insights, or shard keys. The Elastic Cluster uses hash-based sharding to partition data in distributed storage. The compute node and the storage can be separated and scaled independently. Rather than moving data between compute nodes, it copies data between the distributed storage to improve the processing efficiency. Lastly, the DocumentDB provides the specialized query capability for storing and analyzing geographic information. And you can build the application that includes the location information. And here is an example of the geographic query. The DocumentDB has built-in queries for geospatial analysis. And next, I'm going to introduce the management and operation. DocumentDB is a free managed service, so there are not many things you need to maintain. The maintenance will be executed within the pre-specified maintenance window, typically set during the low usage time once a week. When you create a cluster, you can enable automatic software patching. When enabled, the software patches are automatically applied to your cluster during the maintenance window. Regarding the version upgrade, the major versions will be available on DocumentDB once they are released. You can also choose to manually upgrade your cluster to a new version. You can check whether the upgrade will cause the compatibility issues and decide whether to apply the upgrade. Next, let me explain the backups. The DocumentDB provides both automatic backups and manual snapshot. For automatic backups, it occurs every 1 to 35 days. The initial backup is full, while the subsequent backups are incremental, capturing only the changed portion of your data. Note that when your cluster is deleted, its backups are also automatically removed. Additionally, you can create a manual snapshot at any time, which remain until you choose to delete them. A maximum of 100 manual snapshots is allowed. The snapshot can be shared across different regions and the AWS account. And next is monitoring and troubleshooting. You can get DocumentDB metrics with the CloudWatch. The metrics includes the cluster level metrics and the instance level metrics. The cluster level metrics includes the number of connections, storage usage, and more. And the instance level metrics includes the performance metrics such as the read and write IOPS and the latency. With DocumentDB, you can get metrics specific to the query level performance. And you can also enable the performance insight to visualize the capture query latency. Next, these tables summarize the common errors and the troubleshooting in the category such as connection, issues, indexes, and performance. Regarding the connection error, since the DocumentDB instance is in the VPC, the troubleshooting is similar to any other database service. The next and last one is security. As I introduced so far, the DocumentDB is a free managed database service, and the instances are placed in each VPC, so you can use the same security features as other managed services. You can use the VPC for network isolation, encryption, and the IAM for the access and permission management. And next I will introduce the Amazon Neptune. The Amazon Neptune is a free managed graph database service. It offers high performance and reliability. Unlike RDB or NoSQL database, the graph database model data as a collection of the node and edges. The Neptune can be used for analyzing relationships in the social network inside the product recommendation system, the fraud detection, and managing the network topology. Neptune offers the graph processing engine with high performance and high throughput. It provides the automatic backups, data restoration, failover, and enhancing the data durability and reliability. It ensures the data security by offering the data encryption, network isolation, and access control. And Neptune supports the Open Graph Query language, the Gremlin, and the Sparkle. You can handle the various types of graph data. Now I will introduce the design feature of Amazon Neptune, it including its property, structure, and the cost consideration. And here is the sample database of Neptune. Here, for the node names the Alice, Bob, Charlie, the relationship between each node is represented by the edge. And these are query sample of Gremlin and Sparkle, the syntax for the graph-oriented database. This image describes the structure of the Neptune. The Neptune cluster are situated within the VPC. The cluster consists of the multiple instances. The subnets are configured across the minimum of 2 availability zones. A Neptune employs a primary and read replica configuration, where the primary instances support read-write operation and the replicas are read-only. The Amazon Neptune allows you to create the replicas. You can add between 0 and 15 read replicas. On failover, the read replica is promoted to primary instances. And also, you can set failover priority. These rules for the priority are similar to Aurora. And you can specify failover priority for the read replica. The one with the lower number will promote to the primary instance first. If the priority are the same or no priority is specified, the one with the larger size will promote to the primary instance. And any replica will be promoted if it has the same priority and size. A Neptune storage automatically scales in 10 GB increments up to the 64 TB. A total of 6 data copies will be created, 2 in each of the 3 AZ. Neptune uses the column model. It is similar to Aurora, allowing write even up to the 2 out of 6 data copies fail. Also, it is possible to write even if the up to 3 out of 6 have errors. The Neptune endpoint includes the cluster endpoint, leader endpoint, instance endpoint, and the customer endpoint. A cluster endpoint is associated with the cluster and typically connected to the primary instances, which is automatically updated to point to the new primary instance in the event of failure. Leader endpoint connects to the read replica within the cluster are used to distribute a load of read replica. Instance endpoint allows for the direct connection to specific instance within the cluster, and it is used for when the work on the particular instance is required, although they are usually used for a debugging purpose, only since the Neptune automatically handles the instance switching. And furthermore, the customer endpoints can be set up, which are endpoints that can be designed for specific instance or specific groups. The cost component of the Neptune includes the instance, storage, and the data transfer. The instances are built on the hourly basis. If the runtime is less than an hour, billing is calculated in minimum increments of 10 minutes. The unit price varies based on the instance size. The Neptune offers use case for the development and the testing, as well as the production, with the latter being more expensive. The additional changes apply when adding the read replicas. The reserved instances are not available. The storage automatically expands in 10 GB increment up to the 64 TB and is built on the per gigabyte per month basis. The consumed I/O charges a build per million requests. The additional charges apply for backup storage if the total storage exceeds 100%. And the data transfer is billed only for outbound traffic. It is similar to other databases and is charged per gigabyte. Next, I will introduce the management and operation, which includes the maintenance and backup. Firstly, the maintenance is performed during the pre-specified maintenance window. The maintenance time is typically less than 30 minutes. The version upgrades, instance identifier changes, and instance classes changes, which can result in the downtime. In Neptune, you can utilize both automatic backup and manual snapshots like any other database. The automatic backup are incremental and occur every 1 to 35 days, with the first backup being the full backup and subsequent backups being the incremental. There may be increased latency during the backup. When the cluster is deleted, its backups are also deleted. The manual snapshot can be taken at any time to backup the entire storage volume of cluster. Unlike the automatic backup, the manual snapshots are not deleted unless explicitly removed. And these are the tips for snapshot. You can copy both automatic and manual snapshot. You can copy snapshot across the region and account. However, to copy an automatic snapshot to another account, you need to convert into the manual snapshot first. If encrypted, the target account must have permission for the KMS key. The next one is monitoring and troubleshooting. With Amazon Neptune, you can monitor metrics using the CloudWatch like any other database service. The metrics you can get. These are mostly the same metrics as other database services, such as the CPU usage, number of the connection, and the memory capacity. The Neptune stream is the change data capture feature. It's like a DynamoDB streams. You can use it to capture changes in your database in real time and stream them externally. The captured data is stored for 7 days. The stream data is often used in conjunction with Lambda function for use cases such as triggering a database changes event to kick other application or raise alert. This is a summary of common errors and troubleshooting for Amazon Neptune. Again, Amazon Neptune is a managed database, so when it comes to troubleshooting, this is like access denied, permission management. Internal errors are just like any other managed service. The next and the last one is the security feature for Amazon Neptune. The Amazon Neptune's security feature include encryption, authentication, and network isolation. This is like any other database. For encryption at rest, you can use AWS KMS, which also cover backup, snapshot, replicas. To encrypt the existing unencrypted instance, you should create the snapshot, encrypt that snapshot, and then create a new cluster. This process is the same as that of Aurora. You can use IAM for authentication. However, Neptune does not support password-based access control. In terms of networking, Neptune instances operate within the VPC, so you can use the VPC network management tools such as Network ACL and Security Group for enhanced security. Next, I will introduce the Amazon Timestream. Now I will introduce the design feature of Amazon Timestream, it including the property, the structure, and the cost. The Amazon Timestream is the managed database service for time series data. The time series data refers to the series of the data points that change over time. It may use many use cases that handle the time series data, such as collecting the temporary data from IoT, and analyzing the financial transaction and monitoring IT operation metrics. The Amazon Timestream automatically scales up and down, corresponding to the changes in data over time. It can collect, store, and process a lot of time series data in real time. The Timestream has a feature to manage the data lifecycle, where the frequently accessed recent data is in memory, and all the data automatically moves to the low-cost disk storage, and this minimizes the storage cost. The Timestream supports querying the time series data using the SQL. It offers a lot of built-in functions for data analysis, such as moving average and the rate of changes. The Timestream can be integrated with other AWS service. For example, it can collect data from the Amazon Kinesis or AWS IoT Core. And for data visualization, you can use Amazon QuickSight or Grafana with Timestream data. This is a comparison chart of Amazon Timestream and DynamoDB. DynamoDB can also process the time series data and by having a timestamp as attribute. And the Timestream includes more optimized features. The Timestream has been released with the general availability in 2020. So before Timestream was released, the DynamoDB was used to process time series data. This comparison is based on the data type, the performance, storage and the cost, and the query language, the compatibility, and the integration. The Timestream is specialized for the time series data, making it great for things like telemetry data, whereas the DynamoDB is versatile design and make it suitable for wide range of applications that require consistent with millisecond latency. What is the time series data? The time series data refers to a sequence of data points arranged as the function of time. Typically, it records at a regular interval, every minute, every hour, or every day. Because it's real-time and scalable, the Timestream is used for the collecting and processing the time series data from the IoT devices connected to the AWS IoT, and retrieving and processing data in real time, and that has been collected via API gateway and AppSync. On the other hand, if you don't need real-time processing and scalability, you may better to use the Amazon Athena with S3. The Timestream has a function specially designed for time series data, enabling the processing just by calling the function. Since the time series data is acquired regularly, it allows for time-based aggregation, the time series analysis, and the calculations such as the anomaly detection and the moving averages. I'm going to introduce the configuration of Timestream. The Timestream consists of the database and the table, and each of which stores multiple time series data. And time series data consists of the set of records, each with the metrics measured by timestamp, and the Timestream data is described by the metadata or dimensions. Next, I will explain the architecture of Timestream. The Timestream tables are divided into the partitions. The timestream data is typically partitioned by the timestamp. In addition to timestamp, the time series also enables the efficient partitioning based on the attribute. When you create a table, it initially has the single partition called a tile, and grows as the throughput demand increases. Each partition is stored in the shared nothing order, meaning that the partitions do not share the data with each other. The time stream has in-memory and magnetic storage, and frequently accessed data is stored in memory, and less frequently accessed data is stored magnetically. The memory store is replicated across the 3 AZ. It uses the Aurora model and maintains the redundancy. The time stream allows you to use the SQL-like queries, and the query complexity and data size determine your workload fleet. You can query up to petabyte. And this is the architecture image of Amazon TimeStream. Starting from the top, there is a data ingestion layer, a storage layer, and a query layer. By separating the layer, it is possible to scale independently, according to the processing load of data ingestion, storage, and query processing. Again, there are two types of storage layer, in-memory and magnetic. The Amazon TimeStream guarantees a 99.99% availability, and Amazon TimeStream is designed using the Cellar architecture to archive an unlimited scale while guaranteeing the availability. The Amazon TimeStream scaling by simply dividing into the cells. Even if your failure occurs in the one cell, the processing continues in another cell, and it minimizes the impact. Each cell has an endpoint and is seamlessly connected to on the SDK and the TimeStream side. Next, I'm going to introduce the cost structure of TimeStream. Data writes are charged per million writes of 1 kilobyte size, and the queries are charged based on the amount of scanned per gigabyte. The memory store and the magnetic store are charged per gigabyte hour and per gigabyte month. Each unit price varies by region. Also, the unit price may change in the future, so please check the official AWS page when actually using it. Next is management and operation. In the previous slide, I have introduced the timestamps architecture as having the separate layer for ingestion, storage, and query. The Amazon TimeStream supports batch processing for writing and loading the large amount of data. When writing, no schema definition is required in advance. The TimeStream automatically detects the schema definition. The TimeStream typically writes on first write-win basis. Also, writing existing data, the last write-win basis. You can write directly to memory store and the magnetic store. The memory store is optimized for high throughput data write, and the magnetic store is optimized for low throughput writes of slow arriving data. The Amazon TimeStream allows you to store multiple records in a single table row. You can utilize the batch import to import multiple CSV files stored in the S3 at once. This is the comparison table describes how to use the batch and the write record API. For write record API, it is used for smaller data, less than the 10 megabyte. For batch writing, on the other hand, is used to write the large amount of data. The write record API is used to add data to an existing table. The batch writing, on the other hand, is used to populate a new table with a large amount of data. The time stream data, the types includes the flat model and the time series model. And the flat model is consisted of the column and row. It is like the relational database. On the other hand, the time series model can have the multiple record in the one record. The time series model is specific to Amazon Timestream. You typically use the flat model when bringing data in Amazon Timestream from other database services, and you can convert flat model to time series model, and you can also convert the time series model to flat model each other. And this is a comparison table of the flat model and the time series model. Again, a flat model is the data in tabular format similar to the relational database. And with the flat model, you can think of as a regular table with your timestamp in the key, so you can do your analysis with the standard queries. The time series model is a data structure specialized for the time series data and allows the query specialized for the time series data. And next is the monitoring and troubleshooting. This is the list of the main metrics you can get with the CloudWatch. You can retrieve the general information, such as the record information, the query latency, a number of the bytes of data in memory store and the magnetic store. This is the table of the common Amazon Timestream error and troubleshooting. Although it contains really detailed information, but you don't have to memorize everything. The Amazon Timestream is a free managed service that doesn't require to configure the networking and infrastructure, so you don't have to worry about the troubleshooting below the server layer. If the server error occurs, wait and try again, or contact the AWS Support Center. And for authentication and performance, you need to design and address the issues. And next, and the last one is the security feature. The Amazon Timestream is a free managed service, so it offers the same security feature as other free managed services. For encryption, the Timestream supports the encryption at rest and the encryption in transit. When it comes to authentication, you can use the IAM to manage access and permission. With Timestream, you don't need to configure instances and configure VPC and subnet, and therefore you don't need to configure connection settings such as the security groups. By using the interface VPC point, you can establish a private connection. Next, I will introduce the Amazon Keyspace. With Amazon Keyspace, you can run Cassandra workload in AWS environment. Apache Cassandra is commonly used as the backend for large-scale distributed application. It's compatible with CQL version 3 and backward compatible with version 2. Here I'm gonna introduce the features of Keyspace. It is free managed, so you don't need to handle the patching, backups, and the recovery from the failure. And it's scalable, automatically adjusting your table throughput and storage as needed. Operating on the structure, it offers high durability and availability. Plus, it integrates with the various AWS security services. Now I will introduce the design feature of the Amazon Keyspace and the Apache Cassandra. Firstly, I'm going to introduce the Apache Cassandra. In fact, the Amazon Keyspace is the free managed service, so you don't have to memorize the Cassandra's feature, but I will explain for your reference. And first, let's talk about the data structure of Cassandra. The Apache Cassandra has a flexible data model that combines the key value store with the column-oriented data store. Sometimes referred to as the column family structure. In this table, the user ID used as the key, and it features the wide column store, meaning it has an extensive column structure. And moreover, a collection of tables is known as the Keyspace, and which is where the name for Amazon Keyspace comes from. In the column family structure, while it may appear similar to relational database on the surface, but the architecture is different. Within the table, you have multiple key value structure nested under the primary key, which enhances the efficiency of query processing. Here also, the user ID acts as the partition key, grouping each record in what we call the partition. And within each partition, you have the data structure in key value format. Another feature of the Cassandra data structure is that each row has a different attribute. In this sample, only user ID, 102, has the phone number. Each partition can have its own structure of independent attributes, and this allows for a flexible data structure that is unique to compare to other NoSQL databases. In Cassandra, you can manipulate the data using the query language called the CQL, the Cassandra Query Language. The CQL can be written like a standard SQL. Here is the example of creating the key space and the table with SQL. And next I will introduce the architecture of the Cassandra. The Cassandra's node structure is called the ring repository, in which the nodes are organized in the virtual ring structure. And data is distributed to the specific node by a hash function. And each node in the ring has a hash range. For example, here is the sample ring structure with for the A, B, C, and D nodes, where the A is 0 to 25, and the node B has 26 to 15, and the node C 51 to 75, and the node D is the hash range from the 76 to 100. For example, if the hash value generated from the sum data is 85, that data will be stored in the node D. Additionally, the data is replicated across the multiple nodes for redundancy. For example, if the data is read right to the A, the same data is also copied to the neighboring node B and C. And these characteristics make the Cassandra extremely scalable and fault-tolerant. This is a simple example, but in reality, it can handle the millions of simultaneous requests and replicate across the hundreds to thousands of nodes simultaneously. And this enables large-scale request processing, such as in the large-scale social media applications. However, the Amazon Keyspace is a free managed service, so you don't need to configure or manage node. Next, let's discuss the Cassandra's performance. The Cassandra performs in-memory processing to achieve the high-speed data read and write capability, and this reduces the disk I/O when in the reading and writing data, so enhancing the performance. In Cassandra, when write operation occurs, data is first written to the in-memory structure called the mem table. The mem table is a key part of the Cassandra's write path, where the data is initially written in memory, and then periodically flashed to the disk-based SSD table. The Cassandra has two caches, a key cache and a row cache. The key cache stores the location of a partition key, and the row cache stores some entire rows. And these memory and cache structures streamline data reading and write processing, and enable large-scale data processing performance. Next, I will introduce the features of Amazon Keyspaces. The Amazon Keyspace is the serverless, free managed service that requires no server provisioning, patching, or management. Therefore, you don't need to worry about the node management. The Amazon Keyspace stores the 3 copies of your data across multiple AZ. Up to the 6 copies are saved. The Keyspace supports multi-region replication. It creates the active-active replication across the regions. The Keyspace provides a low latency with the millisecond in each region. Therefore, it is used for the application where the geographic proximity is required. The multi-region replication consumes the 1.25 WRUs for each row of the 1 kilobyte of data. The Keyspaces offer on-demand and provisioned capacity model. This is similar to DynamoDB. In on-demand capacity mode, it is suitable when read and write traffic fluctuate. In on-demand mode, you are charged based on the resources you used. And the provisioned capacity mode is suitable for use case where the traffic can be predicted in advance. And you can change the capacity mode even after launching the instance. The Keyspaces manage the resources using the capacity unit. The Keyspaces provide a strong consistency and eventual consistency. The eventual consistency consumes half as many read request units as the strong consistency. The write request unit, the WRU, refers the ability to write 1 kilobyte of data. The Keyspaces are charged based on the consumption of capacity unit. And in provisioning capacity mode, you can configure auto-scaling. You can set the auto-scale threshold from 20% to 19%. Next, I'm gonna introduce the management and operation. The Amazon Keyspace has internally reserved keyspaces. The reserved keyspace listed here are not user manageable. The reserved keyspace includes the system schema, and the system schema MCS, and the system migration info. The system stores the internal data for the cluster. The system schema, which holds the clustered schema definition, and the MCS, which stores the metadata related to the multi-region functionality, and the multi-region info, which stores the deployment information across the multiple AWS regions. In Amazon Keyspace, you can configure the partitioner to control which node in your cluster store your data. The hash value for the partition key is used to generate the token, and the data is distributed using the token. The client can specify the token in select and where to optimize the read and write. There are 3 types of partitioners: the murmur-3, random partitioner, and the default partitioner. The murmur-3 is a non-cryptographic hash function used for the hash generation purpose in the distributed system. Next, I will introduce the best practices for the sharding with Amazon Keyspace. In Amazon Keyspace, you can expand the dimension of your partition key by adding the additional columns. For example, add a random partition key named shard to a table whose partition key is date. The shards take on the random value from 1 to 200, for example. The data is then distributed across the multiple partitions, increasing the parallelism and throughput. However, the query performance may be affected because the distributed data must be merged. For example, the data from the same day might be distributed across the multiple shards. In this case, the querying by date results in the merging distributed data. In this case, you can also make the shard a specific item rather than the random value. For example, if you anticipate that you will be querying based on the date and the name, you may want to set the date and the name as the partition key. In Amazon Keyspace, it supports automatic backup and manual snapshot. Additionally, you can enable point-in-time recovery up to 35 days. Next, I'm going to explain the monitoring and troubleshooting. These are the main metrics for the Keyspace that you can get with the CloudWatch. The Keyspaces, like DynamoDB, is provisioned and built by the capacity unit, and therefore you can make the performance the adjustments by the monitoring consumed and the provisioned capacity unit. The API calls the CloudTrail capture includes a data definition language, such as creating the table and the keyspace, but do not record data manipulation language. The logs that can be retrieved by the CloudTrail include the request parameter, which is expressed in the CQL. And this list shows the common errors and the troubleshooting for Keyspace. You can see the capacity and the throughput errors, which includes the provisioned throughput exceeded exception. In this case, you may need to increase your throughput capacity or adjust your application request rate. If you have the throttling exception errors, you can adjust the request interval or increase the throughput. The errors related to the service availability, which includes the service unavailable exception, which indicates the specified service is unavailable. In this case, you can either wait until the service is available or just check the status of the service health because the database is fully managed. And the request timeout exception is the error indicating the request did not complete in time. In this case, you may want to check your network connectivity, retry the request, or optimize your data model. The access and permission errors include the access denied exception, which means you don't have the proper administration in the IAM. In this case, you will need to review your IAM policy. The next and the last one is the security feature. As I explained, the Amazon Keyspace is a free managed service, so the security settings are similar to other managed database services. Encryption is supported at rest using the KMS, and the encryption in transit using the TLS. You can also use IAM for access and permission management, and for networking, you can use the interface VPC endpoint for private connectivity. Next, I will introduce the Amazon QLDB. The Amazon QLDB is a free managed distributed ledger database that offers the data immutability and the cryptographic verification. The cryptographic verification, which means using the cryptographic techniques to confirm the integrity of data, and this enables the tracking and the verification of transaction history. The QLDB is used in the fields that needs to track and verify transaction data, such as finance, manufacturing, insurance, and the supply chains. The future of QLDB includes the data immutability and the storage of complete transaction histories. This prevents the data tampering and ensuring the reliability. The QLDB records the entire transaction history, and which provides the detailed logs for each item. And it allows the complete traceability of how items have changed. And with QLDB, you can cryptographically verify the data integrity. This assures the data has not been tampered with. It delivers high performance and low latency, enabling the quick processing of large volume of transactions. Because it's a serverless service, the QLDB scales automatically, freeing the users from the managing infrastructure while scaling according to the need. This table summarizes the difference between the blockchain, distributed ledger, and Amazon QLDB. The QLDB differs from the typical distributed ledger technology, as it operates under central authority managed by AWS. Unlike the blockchain and the other distributed ledger that doesn't require the central authority and verify transactions through the peer-to-peer mechanism, but the QLDB centralized around AWS, offering the superior transaction verification, ACID property, and the performance compared to the conventional distributed ledgers. Firstly, I'm going to introduce the design feature of QLDB. Here I'm going to explain the data verification process, the data storage, and the cost structure. The Amazon QLDB, its immutability is achieved using the SHA-256, which is the cryptographic hash function. The QLDB creates a new hash by combining the hash of each block with the previous block's hash. This chain ensures the attempt to alter the part of the transaction, which will cause the cascading mismatch in hash, which leading to the detection. SHA-256, which procedures the fixed length hash value from any given data. The same input always generates the same hash value, and the different input yields the different hash values. The QLDB provides a data verification process that confirms the data immutability, and this validation is performed by the getting the ledger's digest and the block's address, and then comparing these with the retrieved digest. You can get and verify the digest through the Management Console or SDK, and you will retrieve the most recent blockchain digest for specified ledger. By comparing the digest, you can verify the ledger's integrity. If there is any discrepancy between the hash value, thereby indicating the compromise is integrity. Next, I will introduce the storage of the QLDB. The QLDB has journal storage and indexed storage. The QLDB is a free managed service, so you don't need to provision storage. The journal storage stores the all transaction history as an immutable sequence. In journal storage, the actual historical data handled by QLDB is stored. The QLDB generates the hash using the SHA-256, and each transaction is stored as an ordered record in the journal. The data in the journal storage will be copied across 3 availability zones within a region for redundancy. The QLDB performs synchronous replication to multi-AZ when a transaction commit. The indexed storage is the storage for more efficient querying of the transaction contents. The QLDB creates the secondary index based on the data stored in journal storage to speed up the data searches. The QLDB also has the multi-AZ configuration, which maintains consistency even in the event of failure. The cost components for QLDB include the storage and the data transfer. For storage, the charges are incurred per gigabyte month for both journal and indexed storage. Additionally, read and write I/O operations are billed per million requests. Regarding the data transfer, the outbound data transfer is charged on a per gigabyte basis. Next is management operation. As I explained, the QLDB is a free managed service, so you don't have to maintain the instance and the cluster. The QLDB does not provide the backup and restore. However, you can export the data to S3. Next, I'm going to explain the monitoring and troubleshooting. This is a list of metrics you can get from the CloudWatch. Some metrics are the same as in other database services. In QLDB, you can see how much the journal storage and how much the index storage you are using, and what actions are done on the digest. And these are the special metrics for QLDB. The QLDB streams capture the data changes recorded in the journal and sends them the kinesis in real time. You can thereby coordinate the QLDB data change event with other services. The future is like a DynamoDB streams. And this lists the common errors and the troubleshooting of the QLDB. Since the QLDB is a free managed service, you don't have to troubleshoot cluster and instance. In most cases, you will need to retry or contact AWS support. On the other hand, errors related to the storage can be avoided by the user. And next and the last one is security features. Again, because the QLDB is a free managed service, so there are not many security items to manage on user side. And for authentication, IAM provides access control. Encryption is supported for communication and data storage. As for networking, you don't need to deploy VPC, and there is no need to configure the security groups or other settings. If you need a private connection, you can use the interface VPC endpoints. In the previous chapter, I had introduced you all the database services that are included in the Database Specialty exam. Starting with this chapter, I will introduce the services that are in the scope of Database Specialty exam, but were not covered in the previous chapter. First, I will introduce the deployment and migration. Firstly, I'm going to introduce the CloudFormation. The AWS CloudFormation is an IAC, infrastructure as a code service. With CloudFormation, you can describe the specification and setting of the various resources in template using the languages such as the JSON and YAML and execute them. For example, the figure on the right shows an example of the template for the creating the EC2 instance. You may find this is simpler than the creating the EC2 instance in the management console. The CloudFormation is used for the large-scale systems and DevOps service releases. By defining the design and the configuration in the template, you can define the repeatable and the reproducible release definition. I'm going to explain the components of CloudFormation. The CloudFormation component includes the template, stacks, and the target resources to deploy. A template is the JSON and the YAML file that describes the resources and the deployment condition. A unit called a stack is created from the template, which actually creates, modify, and deletes the stack for the resources. And you can use the features called a stack set in conjunction with AWS organizations. The stack set allows multiple accounts to create, modify, and delete stack, and used for a collaborative deployment. And you can also have a nested hierarchy for your stacks. I will introduce an example of YAML template for the CloudFormation. And you can define the type and the specification in the resources field. The value to be used when running the template in the parameter field, and the region where the resources will be placed in the mapping field. And we can include the custom resources in the resources. The custom resources are features to implement the customized logic for resources not natively supported by CloudFormation or executing specific process within the template. The operational characteristics of custom resources are as follows. They are backed by the Lambda function, and this Lambda function implements the custom logic for operation such as creation, update, and the deletion of resources. The CloudFormation triggers this Lambda to perform a necessary operation. Additionally, Lambda posts the result of its operation as a response to the response URL to communicate with the CloudFormation. The use case for the custom resources includes the integration with existing API or system, the operation for AWS services or functionality not natively supported by CloudFormation, execution of complex conditional logic based on the specific conditions within the template. It may be hard to understand with just the text information, so I will provide the sample code for custom resources on the next page. Here is the sample custom resources. You can define the custom resources in the resource field, and you can use the custom resource to call an external web API, such as weather service, and get its response. I am afraid the text is a bit small, but here is a sample code for Lambda function and called on the custom resource. The process is branched according to the request type, and weather information is retrieved by an external API. The weather information is defined in the function, and the response is generated to return the acquired information to CloudFormation. In this way, with CloudFormation's custom resources, you can define external API other than the AWS resources. Next, the helper script are the series of the Python scripts that make it easier to operate the customer resources as part of CloudFormation. These scripts simplify the process of sending the response when creating, updating, or deleting the customer resources from the CloudFormation template. The C, F, N in the prefix stand for the CloudFormation. The CFN response is a Python script that sends the response of customer resources to CloudFormation. The CFN hub is the daemon that executes specified command on the EC2 instance when the metadata is changed. It is used to automatically trigger action on EC2 instances during the CloudFormation stack's update. CFN init retrieves the instance metadata from CloudFormation and sets up the instance using the specified settings. It performs operations such as downloading file, installing the package, and starting the services based on the metadata definition inside the CloudFormation template. There are several other types of the helper scripts as well. Since it might be difficult to understand this form of text alone, I will introduce the specific example on the next page. In this example, an EC2 instance is started and the Apache Web Server is installed and started on the instance. On EC2 instance, you can use the user data to execute a shell script. With user data, you can define the shell script such as web server to be installed on the EC2 instance. When the instance is ready, use CFN signal to notify CloudFormation. And the creation policy is defined to instruct the CloudFormation to wait for a signal from the CFN signal. Next, let me introduce the drift detection. The drift detection identifies the differences between the CloudFormation template and the actual AWS resources. It's useful after building the resources from CloudFormation, especially if the manual changes were made to the resources. The drift detection can be performed at the stack level using the Management Console or CLI. You can set up the management rule to execute the drift detection through the config rule, and this allows you to establish notification or remediation action upon the drift detection. In the bottom right corner, I have an illustration of the drift detection result, where the actual information is listed parallel to the expected value. The blue part indicates the differences, and the red part indicates what has been deleted, and the green parts show what has been added. When building the resources with CloudFormation, and if there are errors in the configuration information, the build may fail. In such cases, you can stop the auto build and roll it back. Using the rollback triggers, you can monitor the application state during the creation and updating of the stacks in the CloudFormation, and roll back the operation if specified alarm thresholds are exceeded. You can also specify the CloudWatch alarms for the CloudFormation to monitor for each created rollback trigger. Here I will show you an images of what rollback look like. If stack creation fails, you choose the method for rollback from retry, update, or rollback, and perform action against the failure. If you choose retry, it attempts the stack operation again without any change. This is useful if provisioning of resources failed due to issue other than template. After resolving the issue, retry from the point of failure. If you choose Update, it updates the template or parameter before trying the stack creation. The stack update begins from where the last operation was interrupted by an error. And if you choose the rollback, it rolls back to the last non-stable state, and this is the default behavior of CloudFormation. And next I will introduce the policies configured in the CloudFormation. The stack policy is the policy used to update resources contained in the stack, and you can prevent the unintentional update by defining the stack policy that specifies the actions to allow or deny. For example, the deletion policy protects the specific resources when deleting the stacks. And here is the sample deletion policy that maintains S3 bucket and the deletion policy that takes a snapshot of EBS volumes. Next, I'm going to introduce the migration services. There are several types of the database migration. The simplest method is to migrate the data from the source to the destination in the batch. It's difficult to migrate the data in the batch. You can also migrate the portion of data first, and then migrate the difference data. The another option is the continuously synchronize the database at the source and the destination. And in this case, you can use the direct connect to migrate the data and quickly over the high bandwidth line. I will go on to explain the migration pattern. The CDC, the change data capture, migrates the full data first time, and only the changed data the second time. When migrating the large amounts of the binary data called the lobs, AWS DMS provides the three options. The first, full lob mode migrates all lobs from the source to target at once. However, full lob mode migrates a large amount of data without a limit, which can reduce the performance. And the limited lob mode sets the maximum allowed lob size for the migration. Exceeding the maximum allowed lob size is truncated, and this is the recommended method as it provides a better performance than full lob mode. The AWS recommended value is 100 MB. The inline lob are the combination of full and restricted lobs. Lobs smaller than the specified size and transferred inline, and lobs larger than specialized size are migrated using the full lob mode. And next is the classification by location. The AWS supports migration within the same VPC and within the different VPC. And the cross-region migration is also supported. You can also migrate from on-premise environment to AWS Cloud. With migration from the on-premises, you can use the VPN or the direct connect. And you will decide on the connection method based on the bandwidth. The next classification by the migration method. If the source and the destination are the same database engine, there are several methods. They create the read replica at the source and promote its primary instances as the destination. They create a snapshot at the source and create a new database from the snapshot at the destination. They create the backup file and store it in the S3 at the source and create a new database from the backup file. And create a new database from the CSV file or use the database engine specific utilities. When the migration between the different databases, the source and the destination will be evaluated for compatibility of the table format, schemas, stored procedure, and function. And if necessary, you can perform the schema conversion in AWS SCT before migration. And next I will introduce the AWS DMS. The DMS stands for the Database Migration Service, which is the service that migrates the database from the on-premise to AWS environment. And it's possible to migrate all the data at once, or continuously migrate to change the data with the incrementally. With common database service such as MySQL, PostgreSQL can be used as the source and the target. Mostly, the DMS supports the latest DBMS, but you should check the supported version in advance from the DMS documentation. The migration types include the migration the existing data, and migrating the existing data and replicating the ongoing changes, and replicating data changes only. Once the data migration is initiated, you can also monitor the migration status. I'm going to show how the migration procedure using the DMS, and this is the simplest method and with no schema conversion. First, create the replication instance from the DMS console. Here, configure the instance type, and the VPC and subnet group, and the storage setting. The instance type and the storage capacity should be adjusted according to the volume of the tasks to be migrated. In this figure, the replication instance, the source database, and the target database are all in the same VPC, but if necessary, set the port in the inbound rules of the security group to allow the connections. And next, create the endpoints for both the source and the target database. At this point, it is recommended to test the connection from the replication instance to the endpoint beforehand. And for RDS, the connection information will be automatically reflected. But for other database services, you will need to enter the connection information such as IAM and user password. And now that the environment is ready, create the actual migration task. In the migration task, you can adjust the migration method, such as the full migration or differential migration. Once the migration task is complete, evaluate the migration, and if there are differences, migrate the different data. Next is the SCT. The AWS Schema Conversion Tools, SCT, is the tool that converts the schema used between the different database engines. The AWS DMS alone does not support schema conversion, so if there is a difference between the schema of the source and the destination database, you should use the SCT to convert the schemas. You need to use the specialized software between the same database engine and SCT between the different database engines. The SCT agent is installed on each client OS, such as Windows or Mac. SCT also supports converting not only schemas, but also code objects such as the stored procedure and function. By the way, AWS recently released a feature called the DMS Schema Conversion, and this course was created in the early 2024, and you can currently use the schema conversion feature from the DMS console screen. This may be updated in the future. For your reference, there are source and target database type and versions that AWS SCT supports. This information is updated frequently, so please check the latest information in the AWS documentation. To give you a cleaner image of SCT, I'm going to provide the example of a schema conversion and the stored procedure conversion. And here we are focusing on the schema conversion from Microsoft SQL Server to Amazon Aurora's MySQL compatibility. This image shows the conversion of the table schema. In this conversion, the identity has been changed to the auth increment, and the data type of the price has been converted to decimal. Due to different data type and keywords available in the Microsoft SQL Server and MySQL, and this conversion is necessary. And the next is the example of the stored procedure. As a case for the stored procedure, consider adding the new product to the product table. Unlike the SQL Server, where the parameter name requires the preceding the @mark, MySQL doesn't need it. Also, the conversion of the parameter for data type is necessary. The declaration and the termination of procedure differ too. I'm going to explain the image of the migration that combines the SCT and the DMS. Suppose we are going to migrate from the source database on-premises to target database in AWS Cloud. First, use SCT to evaluate whether the source and the target schema can be converted. Next, convert the source schema in SCT. The DMS transfers the data from source to the target. Once the transfer is complete, the data verification is performed in the DMS. And if there are the changes to the source data during the migration, the DMS migrates the changed data with CDC. Next, let me introduce to the Snow family. The Snow family is a service that uses the physical storage devices to transfer terabytes of data. It also supports the data transfer from on-premises to S3 and the data export from S3. The Snow family is useful to the transferring the large amount of data from network-restricted environment to AWS Cloud. Conversely, if you want to transfer small amount of data in a network environment with sufficient bandwidth, it is better to transfer it over the network. You can place the orders for the Snow from the console. It takes about 1 week to 10 days for the data to actually be transferred from the order. It is depending on the region. The transfer is really secure because the highly durable physical device, and the data is also encrypted by KMS. This is a list of the Snow family specs for your reference. This specs is the current one, so please refer to the official document for the latest information. This is an image of the migration using the snowball. Again, assume we are gonna migrate from the source database on-premise to the target database in the AWS Cloud. First, use SCT to evaluate whether the source and the target schema can be converted. Next, convert the source schema with the SCT. Manage DMS task and the local task in SCT. The local task includes the Snowball client and the local machine learning, the DMS engine. Transfer all data to S3 on your Snowball device, and this transfer will take approximately 1 week. Next, the DMS transfer the data from S3 to the target database. Once the transfer is complete, the data verification is performed in the DMS. If there are changes to the data source during the migration, the DMS will migrate the change data. If the amount of change data is not large, transfer the data directly from the source to the net target. Next, I will introduce the management and operation. Here again, I will introduce the services that were not fully introduced in the previous chapters. The first one is Amazon SQS. First, let me introduce the monolithic architecture and the microservice architecture. In the monolithic architecture, systems are tightly coupled and run as a single service. And therefore, if any one of the systems spikes, the entire architecture must be scaled. Because of the high interdependency, there is a risk that a single failure will affect the entire system. Conversely, in the microservice architecture, the systems are built as the independent component. Each component executes the independent processes as a single service. Therefore, each service can be updated, deployed, and scaled with minimal impact on the entire system. Recently, it is a trend in the shift from the monolithic architecture to microservices. The Amazon Simple Queue Service, or SQS, is a free managed message queue service. It is the oldest service introduced before the AWS founded. SQS is used for the loosely coupled and asynchronous connection between the systems, such as microservices. If a producer sends a large number of messages to consumer, the consumer may not be able to process the messages, and it may overload the system. And therefore, by queuing the messages, the load can be offloaded. SQS is the most important in integrating the applications. SQS is used for the loosely coupled, asynchronous connection, and the load reduction. It can also be used with the Lambda to set the threshold on the number of the queue and trigger event when the thresholds are exceeded. From this page, I'm going to explain how to manage the queues. Here is a comparison between the standard queues and FIFO, first in, first out. For ordering, the standard queue offers best effort ordering. The messages can be delivered in one order. The FIFO queues offer the guaranteed ordering. Messages are delivered in the exact order. For delivery, the standard queues support at least once delivery. In other words, there is a possibility of duplicate messages. And FIFO supports exactly once delivery. It ensures no duplicate. For throughput, the standard queue supports unlimited number of the transactions, and FIFO supports up to 3,000 messages per second in batch. The standard queue is widely used for the application where message order and duplicates can be considered unimportant. And the use case of FIFO is where the order is critical and no duplicates are allowed. And next, I'm going to introduce the message polling. There are two types of polling, the short polling and the long polling. The short polling returns message immediately, even if the queue is empty, and this is the default setting. The long polling waits for a message to become available sometime, up to maximum 20 seconds. For response time, the short polling returns the message immediately. The long polling takes slower. The short polling may increase the network traffic due to frequently empty responses. The long polling decreases the network traffic by reducing the number of unnecessary responses. A short polling has the advantage of its simplicity, but its disadvantage of the lower network efficiency. And the short polling is set by default. And if you set the long polling, you need to specify the wait time seconds. The short polling is suitable for scenario where immediate response is required, even if its result is empty response. And the long polling is used for the query with a low message volume, or for cost saving in scenario where immediate response is not a top priority. The next I'm going to explain visibility timeout. Visibility timeout is the duration that the message remains invisible to other consumer after a queue has been polled. This means that once a message is retrieved, it is not immediately removed from the queue, but is hidden for a specified period. And during this time, the other consumers cannot receive the message. The message is processed only after the receiving consumer has finished processing it. The visibility timeout can be configured from 30 seconds up to 12 hours. The use case of a visibility timeout is to provide a buffer for reprocessing a message in the event of failure, and this allows the consumer to process the message again. It also prevents duplicate message delivery where there is the connection failure, as the message will remain invisible to other consumer for duration of the visibility timeout. The next is the DL queue. That letter queue is the queue to get the messages that fail to be processed to the source queue. Example use case of dead letter queue is to move another queue when limit of visibility timeout is exceeded, and isolate problematic message to investigate the cause, accumulate the message during the failover. A delay queue has the delay period for messages. This delay period is amount of time between when message is sent to queue and when it becomes visible to consumer. The use case for delay queue includes a scenario where the application on the user side requires time to process messages before new ones are received. Additionally, in a situation where the certain message should be processed in a specific order, ensuring that some messages are not processed before the others. Here is a comparison chart of delay queue and the visibility timeout. They both manage the timing of the processing message, but in different way. The definition of delay queue is the duration for which message is delayed before it becomes available from consumers. Visibility timeout is the duration that the message remains invisible to other consumers. In the delay queue, message remains hidden between the message being sent and available. And with visibility timeout, once the message is retrieved, it remains invisible to other consumers for the duration. The purpose of the delay queue is to introduce some interval for all messages before they can be processed. Visibility timeout is to prevent the message from being processed multiple times. In addition, it provides some interval for the consumer to process a message before it becomes visible to others. The delay queues are useful when you need to postpone the delivery of all the new messages, or when consumer may not be ready immediately to process messages. And this can be useful, for example, when the consumer-side application requires initialization time. Visibility timeout is used to ensure that once a message is being processed, it is not processed by any other consumer simultaneously. It is also useful when the additional time is needed to process or retry a message before it becomes visible again to other consumers. And you can set the queues policy for queues to allow or deny sending or receiving the queues. And you can also share queues by setting up the sending and receiving of the queue between the accounts. But the billing is handled by the account that creates the queue. This is an example of the queue policy. As you see in the action field, the SQS send a message, which means that the principal is allowed to send a message to the queue. And since the SQS is a service for interworking between the services, you need to set a queue policy. In practice, it has often authorization error due to the forgetting to set the queue policy, so you must be careful. And lastly, for your reference, here is the typical API for SQS. The actions on SQS are to be classified into the operation on the queue and the operation message in the queue. You can also set the action on the queue attribute. Next, I'm going to explain the AWS Lambda. AWS Lambda is a function as a service that allows for the construction of actions, the conditional branching based on the event-driven trigger while integrating with the various resources. It is serverless and free managed service, and users are only billed during the function execution. It enables a high availability and cost-optimal function execution. The Lambda supports Java, Node.js, C#, Python, Go, and PowerShell and Ruby. Even if the language is not natively supported, you can define the custom runtime. While Lambda works with the various services, it is necessary to grant IAM permission to execute the Lambda function properly. The Lambda supports a wide range of event-driven use cases. For example, execute function triggers by HTTP requests through the integration of API Gateway and Lambda. Add metadata to data upon its upload to S3 as a trigger. And daily execution of start and stop actions on EC2. The typical architecture of Lambda includes an application on EC2 send a write request to DynamoDB, and then using SQS, the producer and the consumer are separated asynchronously. And if the number of the failed SQS process or the queue weight count exceeds certain threshold, the Lambda's conditional branching issue an alert. This is the Lambda function that adds an item to DynamoDB when the certain number of the message accumulate in the SQS queue. The term, the boto3, at the top is the invocation of AWS SDK for Python. For your reference, the boto is named after the Amazon River dolphin. The Lambda handler is also referred to as the event handler function, serving as the function that processes event in Lambda. And it retrieves the endpoint of the SQS queue and gets the attribute of the SQS queue, approximately number of the messages, and which represents the number of messages queued up. And lastly, there is an if statement that adds an item to DynamoDB when the number of the message exceeds 10. Next, let's delve into the Lambda layer. The Lambda layers are features that package the library and the dependency, so that they can be used and shared across the multiple Lambda functions. In the past, without Lambda layers, it was necessary to upload library and dependency for each Lambda function via zip file. But now, it's common practice to use Lambda layers. In Lambda, you can set version and alias. With versions, you can keep the old and the new code when you make update. When you update the code, a new version is created. And with alias, you can manage the separate environment. For example, you can create the multiple aliases such as for production, deployment, and staging environment. And the ARN will include the both versions and alias. However, the ARN for the initial version does not contain the version number. The next, the billing is based on the number of the function execution. But the Lambda provides a timeout setting to prevent the function from running indefinitely. By default, the timeout is set to 3 seconds, and the maximum execution time per request is 900 seconds. It equals to 15 minutes. And this makes Lambda useful for relatively short batch jobs, but it's not suitable for processes that exceed 15 minutes. And the other quarter includes the maximum of the 512 megabytes data storage in the temporary directory. The total size for function and the layer is 75 gigabytes, although this can be increased upon request. The concurrency limit is 1000 simultaneous execution per region, but this too can be increased upon request. The memory allocation starts at the 128 megabyte default, and it can go up to over 10,000 megabytes. The maximum of the 5 layers can be assigned to a function. The next I'm going to introduce tools for monitoring and troubleshooting. The first one is Amazon CloudWatch. The Amazon CloudWatch is a comprehensive monitoring tool. It has a very large number of the features and can monitor all the services. The CloudWatch monitor has a function such as the triggering the status changes to generate action and alert. And this is the overview of the CloudWatch functions. The CloudWatch collects the logs and metrics and generates the alarm when they exceed the threshold, and then notify via SNS and execute the necessary action in conjunction with the Lambda function. The CloudWatch captures logs from the resources and analyzes the logs. You can set the log retention period from 1 day to indefinitely, and which is useful for audit purpose. And the logs can be filtered to identify the frequency of errors. And here is an example of a query of VPC flow logs for particular time frame and IP addresses. Then assume you have over 1,000 records. It's important to use filters to extract only necessary data information. And next, the CloudWatch metrics is a grouping of system health and performance for a specific time period. There are metrics that are automatically obtained from various services and metrics via APIs. And you can specify the standard metrics such as CPU usage, HTTP request, disk usage, and as well as custom metrics. You can get the logs and the metrics from the on-premise resources by installing the CloudWatch agent on a Linux and Windows server. And next is the CloudWatch alarm. The CloudWatch alarms are generated when the preset thresholds are exceeded. or when anomalies are detected. In addition, the triggers by the alarm, the notification can be sent via SNS, and you can take some actions. And you can configure statics and the duration of alarm. The metrics of the alarm includes the OK, alarm, and the insufficient data. The CloudWatch event is the feature that detects changes in the status of resources, and it can stream the information in real time. With CloudWatch event, based on the events and rule, you can trigger action on the specified target. The event sources can be categorized into the schedule and the event. For instance, you can define the event to execute the action on a specified day of the week, and trigger an action when the metrics exceed a particular threshold. The targets can be defined using rate or coulomb. The CloudWatch event often works with a Lambda function, where the certain event triggers the execution of another resource. And next I'm going to introduce AWS CloudTrail. The AWS CloudTrail is a service that logs user activity and API operation from the CLI, SDK, and console. You can record the trail of who did what and when. The CloudTrail's events are categorized for management event and the data event. The management events include the security group setting, device registration, and the data event includes the operation on S3 bucket, execution of Lambda functions. In addition, when the CloudTrail insight is enabled, you can detect the anomalies the activity logs. And this is a sample trail of API call of EC2 instance. In order to make trails secure, the CloudTrail provides some security features. And you can store the past 19 days trails for free. And for long-term storage, you can save on the S3 bucket. The S3's trails are encrypted with SSE S3. And if you need to use your own key, you can use KMS. If you want to avoid changing or deleting the trails for auditing purpose, it is recommended to take the following measures. First, use KMS and control access KMS with IAM. Use S3 bucket policy and IAM policy. And set up MFA delete to prevent the accidental deletion. They create the dedicated accounts for trail storage, which means the separates of operation and the security administrator. And set up the digest file to keep a hash value of the trail, and this will serve the evidence that the trail has not been tampered with. And next, I'm going to introduce AWS Config. AWS Config is a service to log configuration changes of AWS resources. It's used for change management and getting change history. You can check the history of who and what changes, when, and to what extent in the event of failure. For example, you can get change history such as configuration change, for example, software configuration changes on EC2 instance. And you can also use the query to retrieve the history under specific conditions. The config rules enable you to automatically evaluate your configuration. With config rules, you can assess how well your resources configuration align with the compliance, best practice, and other guidelines. And there are two primary types of the config rule. The AWS managed rules are predefined rules. For many services, AWS provides a managed rule that corresponds to common best practice. And the customer managed rules allows you to define custom rules for your resources. It's particularly useful for unique use cases that are not covered by AWS managed rules. Next and the last one is database security. In this chapter, I will explain IAM, data encryption, and network security. The first one is IAM. The AWS Identity and Access Management (IAM) helps you to securely control access to resources. With IAM, you can centrally manage users, security credentials, and permission that determine which AWS resources users and application access. The IAM's component includes the policy, users, groups, and roles. The IAM policy is an object that defines permissions. It's attached to identity or resource, determine what actions are allowed or denied. It's written in JSON format and can be granular, specifying the permission types, resources, and conditions. The users are entities that you create to represent the person or the service who uses them. The IAM users consist of the name and password to sign into the console and the key pair with API. The IAM group is a collection of IAM users. You can use the group to specify permission for multiple users, which can make it easier to manage the permissions. The IAM role is a secure way to delegate the permission without sharing the credential. You can use roles to delegate the access to users, applications, or services. For IAM users' authentication, you can sign in ID and password or key pair. By enabling MFA, you can enhance security. While ID and password are memory-based, but the key pair has a risk of leakage, so AWS suggests not to use access key as much as possible, but to use alternative authentication method. And here recommended method for managing key pairs follows the principle of least privilege with IAM role. Avoid hard-coding the key pair, set them as an environment variable instead. Use IAM roles or cognate as the alternatives. Implement the IP address restriction for users with the configure key pair. Perform the periodic key rotation, and periodically check the usage of access keys. By assigning the permission to IAM group and adding the IAM users to groups, you don't have to grant permission to each individual users and reduce the risk of the improper permissions. This is an example of an IAM policy in JSON format. The version is set to 2012-10-20, and this remains a constant for a while. Under the statement, you can set multiple conditions. SID or seed allows you to set arbitrary identifier. In effect field, you can set either allow or deny. And for action, you can specify the targeted API action. There are the various kinds of APIs for each resources, allowing you to define them in detail. In this example, an asterisk is used, which means to allow any action. Conversely, if you specify an asterisk and set the effect to deny, it will deny all action. For resources, you can describe the target resource. And under condition, you can describe the conditional clauses. Now I'm going to explain the details about the condition. Within the condition field, you can set the detailed condition. The tables here is a summary of condition. The string equals determine if the string are an exact match. For example, it determines if the resource name matches. The numeric equals determine if the numbered match. And bools or boolean can define binary condition of true or false. For example, a condition can be defined to be valid only when encrypted communication is enabled. ARN equals determine if the ARN match, and the data equals determine if the date match. The next I will introduce the category of IAM policies, which can be either identity-based or resource-based. The identity-based policies is attached to identity, like a user, group, or role. It grants permission to identity to perform a specific action on specific resources. And there are two types in the identity-based policy: the managed policy, which creates and managed by AWS or the user, and the inline policy, which is specific to the single identity. The resource-based policy is attached to the resource, like an S3 bucket or SNS topic. It grants specific identity permission to perform a specific action on that resources. It often includes a principal element to specify who is allowed or denied access. The resource-based policy typically includes a principal element that specifies who is allowed or denied access, and while identity-based policies do not have the principal element. I have talked about the IAM policy, and I want to point out some common patterns for the resources-based policy. The S3 as the origin of the CloudFront, the Lambda, and the SQS are often used with many other services. Especially Lambda and the SQS work with other services, so you need to set the proper policies. Next, I will explain the related policy. The permission boundary is a managed policy that sets the maximum permission. It is useful for use case where IAM entity should not grant them full admin rights. The permission boundary limits the permission the new role user can get. The Service Control Policies, or SCP, is the roles for AWS organizations. SCPs define the maximum permission entity within the account, effectively acting as a guardrail. And for example, even if an IAM user in the organization has the full S3 access, an SCP can deny that permission. The session policy is dedicated for assuming a role and federated user. It limits permission for the session, and it interacts with the identity-based and resource-based policy to determine the effective permission. It cannot grant more permission than those policies, but can further restrict them. Next is AWS KMS. AWS KMS, or Key Management Service, is a managed service designed to simplify the creation and the control of encryption keys. It manages the Customer Master Key (CMK), which enables the generation, encryption, and the decryption of the key. The data is encrypted using the Customer Data Key (CDK), which in turn are encrypted with the CMK. AWS KMS supports the customer-managed CMKs, which are created and managed by AWS customers, and AWS Managed CMK, which are created and managed automatically by AWS. There are two main encryption methods, symmetric and asymmetric. The symmetric encryption uses a single key for both encryption and decryption. On the other hand, asymmetric encryption uses the public key and the private key. It may be more commonly recognized as the secret key cryptography or public key cryptography. The asymmetric encryption is a newer service and is more secure. And here the image shows the asymmetric encryption. And first, the target file is encrypted using the encryption key. The encryption key itself is encrypted. During the decryption, the key first decrypted. The decrypted key is then used to decrypt the file. It is risky to use the same key for a long time due to the risk of compromise and key leaks. Therefore, it recommends to rotate the key material once every year. If you need a more frequent rotation, you can use the customer-managed CMK or employee manual rotation. Even after key rotation, the previous key materials are retained, ensuring that you can still decrypt the data. Only the key material undergoes rotation. Other properties such as key ID, key ARN, the policy, and the permission remain unchanged. You can enable, disable, or delete CMKs. Once a key is deleted, it cannot be recovered forever, which poses the risk of losing the ability to decrypt the data encrypted with that key. And therefore, if you think a key is no longer needed, it's first logically removed and physically deleted after a waiting period of 7 to 30 days. During this waiting period, if the key is used by someone, it will be detected by the CloudWatch and CloudTrail. It is recommended to disable unnecessary keys first, rather than deleting them outright. And you can set the key policy. The key policies can be used to control the access to the CMK. The key policy can be used in conjunction with IAM policy, where IAM policy controls the access to the users and the roles, and the key policy controls access to the CMK. In other words, key policy is the resource-based policy. The key policy can be described in the JSON format as shown below. By specifying the action field in the key policy, you can restrict the permissions. The sample on the left is the action of the key administrator. The key administrator can manage the key creation, activation, deactivation, deletion, scheduling, and so on. And on the right is an example of key user actions. The key user can encrypt or decrypt using KMS, generate data keys, and so on. Next, I'm going to explain the AWS Secrets Manager. AWS Secrets Manager is a service that manages the lifecycle of the database credential and the secret information such as password. With Secrets Manager, you can retrieve the secret information via an API and can use it for authentication. The secret rotation is supported. The rotation is performed by Lambda function. If secret information is included in the application code, there is a risk of leakage in the event of the failure. In addition, you have to update the password within the application code. This is not a reasonable way. It recommends that the secrets not be embedded in the code, but should be stored in the Secrets Manager. The Secrets Manager and the Parameter Store have some common functionality, and I'm going to introduce differences. The Secrets Manager is designed for managing and rotating secrets like a database credential, API keys, and other sensitive information. The parameter store is a part of System Manager. It is designed for storing the configuration data, including the plain text or encrypted strings, such as password, database strings, and license code. The Secret Manager has the built-in functionality for automatic rotation. The parameter store does not have automatic rotation. The rotation logic must be implemented manually. The Secret Manager generally has a higher cost due to its automatic secret rotation feature and other advanced features. The parameter store offers a free tier and an advanced tier with more features. The Secret Manager is deeply integrated with the database services. The parameter store is more widely used with the other system managers' capabilities. The next and last one is network security. Here is a list of network security services. Among these, the security groups and the VPC feature often appears on the exam in the context of the database. I will introduce the traffic routing in the VPC. You can control traffic by security groups and network ACL. The security groups are configured for each instance, and the network ACLs are configured for each subnet. A security group is associated with the ENI, and the security groups are stateful, and the network ACLs are stateless firewall. And by default, security groups allow internal communication, and network ACLs allow all communication. Next, this page summarizes whether or not security groups can be set. A security group is a virtual firewall that you can configure for the service running with your VPC. With IaaS and paths, such as database instances, you can configure the security group. Conversely, you cannot set up security groups with a serverless service. For example, if a question on the exam includes the option for managing network access to the serverless services with the security groups, that option should be incorrect. I have summarized the points to consider when accessing a resource in VPC B from the resources VPC A. And you need to consider the IAM roles in the EC2, a security group in VPC A, S3 bucket policy, and VPC endpoint. In this image, the VPC A has the EC2 instance, and VPC B has an S3 bucket. This is an example of IAM role to attach to EC2 instance. Here, the get object and the put object are allowed inside the action field. If we want to retrieve and analyze the CSV file of a packet file in S3, you need to get object. On the other hand, if we want to add or change new data, you need to add put object. Specify the ARN in the resource field, and you need to follow the law of the least privilege. When setting up the security group, you need to specify the protocol and address range, and it is similar to the firewall. And if you forget to specify inbound and outbound rules for the database instance, the access error will occur. And just like IAM policy, you should configure the S3 bucket policy according to the law of the least privilege. Here, the only allow access from the specific VPC endpoint, so we use the string not equal condition to deny unnecessary permissions. The errors often occur when the data analysis tool forgets to set access permission to the resources being analyzed. When accessing data in one VPC from another VPC, you need to consider the network setting of the access source and the destination, as well as the IAM permission setting. The question is sometimes asked in the exam test, so I'd like you to take a look at the necessary element related to the authority. In Chapter 4, in the summary of this course, I will introduce the pricing calculator, support plan, marketplace, and learning resources. AWS Pricing Calculator is a tool to help users to estimate their cost. You can input your resources usage, such as the number of EC2 instances, and the calculator will provide a detailed breakdown. You can estimate cost, save and share the estimate and get recommendations. For your reference, the image shows pricing trends for EC2 and S3. The prices of cloud have been going down over the years because of the competition between the cloud providers and the improvement in the technology, and these prices are expected to keep dropping. The prices and the service from the all cloud services changes often, so it's important to stay updated. Next, the AWS Partner Network, or APN, is a global program whose purpose is to identify AWS partners who can assist the clients. The APN consists of two types: the consulting partner that help clients design, architect, build, migrate, and manage their workload on AWS, and the technology partner is the independent software vendors that develop and offer software solutions optimized for AWS. They provide the services such as SDK, API, and other tools to assist in the integration of client applications with AWS services. The partners in the APN can get the benefit, including the training and certification program, and the marketing and sales support, the technical support, and access to AWS resources. This is the list of AWS support plans. By opting for a pet plan, you can receive the more comprehensive support. The farther to the right you go, the more extensive support becomes, including the technical support from the terms and the faster response times. The AWS repost is the Q&A community where members can post questions, and the members of the community provide the answers. With AWS Marketplace, you can purchase the software and the services from the third-party vendors. You can utilize the marketplace to discover the solution tailored to your specific need. For example, in EC2, you can purchase the machine image with the software from third-party vendors. And here are the official AWS learning resources. While I've covered what's on the exam, I recommend for you to check the official document. AWS also has a training site, the Skill Builder, with the sample questions. The AWS announces new service at events like re:Invent and the AWS Summit. If you use the AWS often for work, it's good to attend these events. Finally, thank you for staying with me throughout this course. I also offer courses on AWS, Google Cloud, and Microsoft Azure. Stay tuned as I will expand my offerings in the future. With that, we've come to the end of this course. I hope the content has been valuable to your learning journey. Thank you for dedicating your time with me, and I wish you success.